Everyone, please be ready. Our ceremony will begin shortly. Please, everyone who are outside the room, please enter the room soon before ceremony begins. Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. Rabbi sohri sodli wa yasirli amri wahlul uqdatam min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh. A very good morning and a warm welcome to all guests and participants. It's our great pleasure and honor to welcome all of you to the 5th International Conference on Coastal and Delta Areas, ICCDA 2023.
The 5th ICCDA is hosted by Universitas Islam Sultan Agung Semarang. Our main co-host is Universitas Islam Al-Azhar, West Nusa Tenggara. Another co-hosts are Rotterdam University of Applied Sciences, the Netherlands, and then Universitas Semarang, Universitas Lancang Kuning Riau, Universitas Sanggabuana Bandung. Ladies and gentlemen, we turn back memories of previous conference. The first ICCDA was held on February 20th, 2015. The second ICCDA was held on November 19th, 2015. The third ICCDA was held on September 26th, 2017. The fourth ICCDA was held on September 21st, 2021. And today, October 19th, 2023, we are conducting the 5th ICCDA.
Well, ladies and gentlemen, our topics today are plan, design, and construction to develop smart infrastructure in coastal and delta area, climate change challenge, disaster mitigation, and infrastructure in coastal and delta area, sustainable development in coastal and delta area, and policy, socio-economic, law, and multi-aspects to build environment in coastal and delta areas. Well, ladies and gentlemen, I am Mihartini and also my partner,
Adi Prayuda, your MC for today's event. His Excellency, Director of Universitas Islam Sultan Agung, Unisula Semarang, His Excellency, Director of Universitas Islam Al-Azhar, Unizar, West Nusa Tenggara, Honorable, the Indonesia Minister of Public Works and Housing, Honorable, the ad interim of West Nusa Tenggara Province Governor, Honorable, ad interim of Bima Mayor, Honorable, all invited speakers, respectable all participants, ladies and gentlemen.
Before getting started, let me make sure you have a stable internet connection, and also please mute your microphone and mobile devices and foreseen noise during the event, especially for online participants. We remind you to rename your name of participant by room _ paper ID _ name. Thank you. Well, ladies and gentlemen, now we are going to listen to the national anthem of Indonesia, hymn and march of Unisula. So everyone, we please you to stand up.
Siapkan insan khairul ummah dengan Al-Quran hadis, berjuang harapkan ridha Allah. Ayo berjihad fisabilillah, tebarkan ukhuwah Islamiyah dengan semangat budaya yang amanah dan istiqomah. Yuk cintai Allah, ikuti Rasulullah, sayangi sesama, dapatkan rahmat dan keberkahan. Yuk cintai Allah, ikuti Rasulullah, sayangi sesama, untuk kebahagiaan bersama. Berjihad fisabilillah, tebarkan ukhuwah Islamiyah dengan semangat budaya yang amanah dan istiqomah. Yuk cintai Allah, ikuti Rasulullah, sayangi sesama, dapatkan rahmat dan keberkahan. Yuk cintai Allah, ikuti Rasulullah, sayangi sesama, untuk kebahagiaan bersama. Allahu Akbar, Allahu Akbar, Allahu Akbar, Allah Maha Besar. Allahu Akbar, Allahu Akbar, Allahu Akbar, Allah Maha Besar. Allah Maha Besar, Allah Maha Besar.
Everyone, please sit down.
Ladies and gentlemen, without any further, now we would like to welcome Mr. Jamul Khair, SPDI, to recite the Quran. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Ayyuhalladzina amanu taqullah. Ayyuhalladzina amanu taqullaha wal tanzur nafsum ma qaddamat lighad. واتقوا الله إن الله خبير بما تعملون واتقوا الله إن الله خبير بما تعملون بسم الله الرحمن الرحيم شهد الله أنه لا إله إلا هو شهد الله أنه لا إله إلا هو والملائكة والملائكة وأولو العلم قائما بالقسط لا إله إلا هو العزيز الحكيم شهد الله أنه لا إله إلا هو والملائكة والملائكة وأولو العلم قائما بالقسط لا إله إلا هو العزيز Sadaqallahul khaliqul azim. Assalamualaikum warahmatullahi wabarakatuh.
Thanks to Mr. Jamul Hair, SPDI. The next agenda is welcoming speech and opening remark by Chairman of 5th ICCDA. To Mr. Arisentani, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi arsala rasulahu bil huda wa dinil haq liyudhhirahu ala dini kullihi wa kafa billahi syahida. Ashhadu an la ilaha illallah wa ashhadu anna Muhammadar Rasulullah. Allahumma sholli ala sayyidina Muhammad wa ala alihi wa sahbihi ajmain, amma ba'd. Honorable General Secretary of Public Works and Housing, on behalf of the Minister of Public Works and Housing, Insinyur Muhammad Zainal Fatah, Honorable the Chairman of West Nusa Tenggara Bapeda, on behalf at Interim Governor of West Nusa Tenggara Province, Dr. Insinyur Haji Iswandi MSI, Honorable President of Pesantren Luhur Al-Azhar Foundation, Dr. Insinyur Nanang Samudra KA MSc, Honorable Director of Unisula, Profesor Dr. Haji Gunarto SH SEAKT MHUM, Honorable Director of Unizar, Dr. Insinyur Muh Anshar MP. Distinguished keynote speakers, presenters, and all participants, very good morning. On behalf of the organizing committee of the 2023 5th International Conference on Coastal and Delta Areas, it is my great honor and pleasure to have the opportunity to deliver this opening message today. To begin, I would like to express my warmest welcome and thank our distinguished keynote speakers, as well as all presenters of ICCDA 2023. Furthermore, I would like to convey my sincere gratitude to the committee, reviewers, and all people for their endeavor to support this event. As it is known, ICCDA 2023 is held in a hybrid format by the Faculty of Engineering, Sultan Agung Islamic University, or Unisula. The primary goal of this conference is to promote research and development activities, as well as a scientific information exchange among researchers, developers, engineers, students, and practitioners all around the world. We believe that this event will not only allow the participants to gain their current knowledge of science and technology, especially in coastal and delta areas. However, this ICCDA will also benefit as a starting point to build a broad new network, which in turn will facilitate any potential collaboration to attain the mission of immaculate eco-engineering development. So, let us make all session and discussion fruitful and enjoyable. Distinguished speaker, presenters, ladies and gentlemen, the ICCDA 2023 offered 4 topics. The first, plan, design, and construction to develop smart infrastructure in coastal and delta areas. Second, climate change challenge, disaster mitigation, and infrastructure in coastal and delta areas. Third, sustainable development in coastal and delta areas. And the last, policy, socioeconomics, law, and multi-aspects to build environment in coastal and delta areas. From all these scopes, ICCDA 2023 received 110 submitted research papers. Through the double-blind peer review process, the committee carefully selected 86 research papers that will be presented at this conference. After completing the conference and all revision process, the committee will submit the full papers to IOP conference series. These publishers will perform quality checks on the submitted papers, and only those that pass that checks will be published. Therefore, in my capacity as conference chair, I wish that all presenters and others will give their best efforts to refine their papers for a successful future publication with the IOP. This conference will be held in 2 sessions, with the first session reserved only for the invited speaker and the second session used for the panel session for each presenter. So, I would like to take this opportunity to remind all of our speakers and moderators to stick to the schedule and prevent any session from running over time. Distinguished speaker, presenters, ladies and gentlemen, I want to thank everyone who attended for taking part in this conference. You will undoubtedly find this conference enjoyable with many prospects for future research collaboration, as well as gratifying in adapting new information. We really appreciate everyone who helped make this conference successful, whether directly or indirectly. We also thank all of the sponsors for their kind of support. Last but not least, I would like to thank the organizing committee for their dedication, patience, and unending help in making this event success. I pray for Allah to bless you. Finally, once again, thank you for your invaluable contribution and participation in the success of this event. Have a great experience at this hybrid conference with Sultan Agung Islamic University and Al-Azhar Islamic University. Let me read a little rhyme. Pantai Singgi elok nan indah, tak kalah cantik pula Mandalika. Semoga acara ICCDA 5 sukses dan cerah untuk keberlanjutan kawasan pantai dan delta. Thank you very much. Matur suwun, tampi asih. Wallahul muwafiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much to Mr. Adi Sentani, and what a beautiful rhyme for you. The next speech is going to be delivered by Rector of Universitas Islam Sultan Agung Semarang to Professor Dr. Gunarto SHM Hum. The floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable Keynote Speaker, fellow professor and presenter, ladies and gentlemen. It is a great honor for me to welcome you to the 5th International Conference on Coastal and Delta Areas, hosted by Faculty of Engineering Unisula Semarang. We are honored to collaborate with Rotterdam University of Applied Science, Al-Azhar Islamic University, Sangga Buana University, Lancang Kuning University, and Semarang University. Unisula has emphasized the important mission of educating and developing people to grow and serve the world civilization and Islamic science. We are aware that research contribution to publishing and implementation of research product is crucial to realizing the objective. In order to debate a variety of connected topics, share experience, and reflect collectively about the future we envision for our future generation. This conference brings together science from all over the word. I am confident that the subsequent deliberation and discussion will advance more organization study of the coastal and delta area. The 5 ICCDA is set up as an endeavor to enhance knowledge as treasured in the Quran for men, to make attempt to modify some of the present realities of our immediate surrounding, particularly in coastal and delta areas. The Quran exhorts Muslims to seek knowledge through conducting research in an effort to find answer to the myriad of issues that humanity is now facing. The imperative use to find the answer would significantly increase our understanding of Allah subhanahu wa ta'ala, generosity as the creator and his wisdom. Ladies and gentlemen, I would like to express my highest appreciation to all invited keynote speaker and invited plenary session speaker and all presenter and participants who will make this conference meaningful. I am sure the presentation and discussion will enrich and further strengthen the commitment to improve the quality of life of humankind in coastal and delta areas. Finally, I also thank all the chairperson and committee member of the conference. I wish all of you a great conference and make new acquaintances during the conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, the next welcoming speech is from Rector of Universitas Islam Al-Azhar to Dr. Insinyur Muhammad Ansyar MP. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera. Semoga rahmat dan berkah Allah Subhanahu wa taala senantiasa terlimpahkan kepada kita semua. Amin. Amin ya rabbal alamin. Yang terhormat Bapak Gubernur Nusa Tenggara Barat, dalam hal ini diwakili oleh Kepala Bapeda, Bapak Dr. Insinyur Haji Iswandi. Yang terhormat Ketua Yayasan Pesantren Luhur Al-Azhar, Bapak Dr. Insinyur Haji Nandang Samudra, KA MSc. Yang terhormat Bapak Rektor Universitas Islam Sultan Agung, Bapak Profesor Dr. Haji Gunarto SH MHum. Yang terhormat para speaker dan presenter. Ladies and gentlemen, good morning and warm welcome to Lombok. We are very pleased to welcome you to this event. As we know, the world in general facing many challenges, mostly related to climate change. The impact of this phenomenon is highly evident in this rise of sea level, resulting in number of after effect catastrophes such as numerous types of flood, coastline change, land loss, and many catastrophic side issues. Indonesia, as an archipelago country, has been trying to address issue for decades. In direction of achieving the goal engineer faculty of Universitas Islam Sultan Agung atau Unisula and University Islam Al-Azhar are committed to address the issue through the international conference. ICCDA, with this object in bringing together leading academic science, research, and scholar from around the world, sees those issues and opportunity in generating solution so that government holistically view and concentrate various lens talking society related problem. Therefore, I invite all of us to see those concerning problem in positive ways. At least see this very cloud has silver lining. I wish we all can learn at least one silver lining through ICCDA. This is the main goal of today's event. So everyone, I hope I can get faithful result upon this event. Finally, as we also focus on achieving the SDGs along with our long-term goal of university, today's event is many efforts to achieve the goal. Hopefully we can significantly give more contribution to the world advancement in the near future. To all our distinguished guests, attend and student, thank you and welcome again. Please embrace academic environment in the minutes. Thank you. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
The last welcoming speech will be delivered by Interim Governor of West Nusa Tenggara Province, will be represented by the Head of Development Planning Agency at sub-national level, West Nusa Tenggara. To Dr. Insinyur Iswandi, MSI, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hadirin yang saya hormati, mewakili Gubernur Nusa Tenggara Barat, Bapak Dr. Andes Haji Lalu Gita Aryadi MSI, yang dalam forum ilmiah ini tidak berkesempatan hadir secara langsung. Saya ditugaskan untuk mewakili dan membacakan sambutan beliau yang telah dipersiapkan secara tertulis. Namun sebelumnya perkenankan saya menyampaikan salam dan permohonan maaf beliau dengan ucapan Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Bapak Menteri Pekerjaan Umum dan Perumahan Rakyat Republik Indonesia, Bapak Insinyur Muhammad Basuki Hadi Mulyono, MSc, PhD, atau pejabat yang mewakili. Yang saya hormati Bapak Ari Sentani, STMSc, Bapak Rektor Universitas Islam Sultan Agung, Bapak Profesor Dr. Haji Gunarto SHMH, Bapak Ketua Yayasan Pesantren Luhur Al-Azhar, Bapak Dr. Insinyur Haji Nanang Samudra, MSc, Bapak Rektor Universitas Islam Al-Azhar, Bapak Dr. Insinyur Muhammad Ansar, MP, para narasumber dan seluruh hadirin peserta dan undangan ICCDA kelima yang saya hormati. Alhamdulillahirabbil alamin, berkat limpahan rahmat dan hidayah Allah Subhanahu wa taala, Tuhan yang Maha Kuasa, berbahagia sekali saat ini saya dan kita semua masih diberikan kesempatan dan kesehatan untuk dapat mengikuti acara International Conference of Coastal and Delta Areas. Atas nama pemerintah Provinsi Nusa Tenggara Barat, saya menyampaikan ucapan selamat datang kepada Menteri Pekerjaan Umum dan Perumahan Rakyat Republik Indonesia, Bapak Dr. Insinyur Muhammad Basuki Hadi Mulyono atau pejabat yang mewakili, serta seluruh narasumber baik yang berasal dari dalam negara Indonesia maupun dari luar negeri. Saya menyambut baik dan memberikan apresiasi atas diselenggarakannya konferensi internasional yang akan membahas isu-isu penting seputar kawasan pesisir dan delta ini. Berbagai topik yang diangkat di dalam forum ini sangatlah relevan untuk dikupas bersama karena kawasan pesisir dan delta memiliki berbagai fungsi yang sangat penting baik dari segi ekologi, sosial maupun ekonomi. Hadirin peserta seminar yang saya hormati, sebagaimana kita ketahui bersama, wilayah pesisir adalah ruang interaksi antara ekosistem darat dan laut yang dinamis dan saling mempengaruhi. Ini merupakan aset yang sangat berharga dan strategis bagi pembangunan suatu negara. Wilayah pesisir merupakan kawasan yang mempunyai potensi besar untuk dikembangkan, dan pengembangan kawasan pesisir sebagai kota mempunyai nilai yang sangat strategis untuk dapat dikembangkan menjadi kota industri, pelabuhan, pembangkit tenaga listrik, rekreasi, dan konservasi. Namun, disadari pula bahwa potensi besar dan wilayah pesisir ini juga dihadapkan pada tantangan dan masalah yang serius, terutama berkaitan dengan perubahan iklim. Dan oleh karena itu, mudah-mudahan di dalam forum yang terhormat ini, berbagai masalah yang kita hadapi berkenaan dengan potensi pesisir dan delta ini dapat memberi solusi bagi kemajuan ilmu pengetahuan dan kesejahteraan masyarakat pada masa-masa yang akan datang. Oleh karena itu, dengan adanya konferensi ini menjadi sangat penting bagi wadah untuk berbagi pengetahuan, menggali solusi inovatif, dan membangun kemitraan untuk menjawab panggilan guna meningkatkan kemajuan pembangunan daerah dan bangsa kita. Demikianlah sambutan yang dapat kami sampaikan, teriring harapan bahwa penyelenggaraan konferensi ini berjalan dengan lancar dan sukses. Amin ya rabbal alamin. Penjabat Gubernur Nusa Tenggara Barat, Dr. Andes Haji Lalugite Aryadi, MSI. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, please enjoy our montage of Unisula and Unizar, and also from sponsor of the event.
Universitas Islam Sultan Agung Unisula was founded by Sultan Agung Wakaf Foundation on May 20, 1962 in Semarang, Central Java. Unisula gives an important contribution to the world of education, and now it continues to grow and develop to become the best Islamic university in Indonesia.
Alhamdulillah, by the leadership of the Rector, Professor Dr. Gunarto SHMH, Unisula successfully achieved superior accreditation. Unisula is committed to achieve the vision of raising Khairul Ummah generation. Khairul Ummah generation is the best generation to create a generation who will faith, devote, and doing goodness. To achieve this, Unisula will be persistent in implementing Islamic academic culture and the concept of Birrul Walidain campus. So it is expected to raise a competent generation, gracious-hearted, and also caring and devoted good parents.
Pernahkah terbayangkan Anda menjalani proses belajar di perguruan tinggi yang fokus mengembangkan ilmu pengetahuan yang berwawasan kepariwisataan dan berdasarkan nilai Islam rahmatan lil alamin? Selamat datang di UNIZAR, Universitas Islam Al-Azhar, sebuah kampus di Pulau Lombok, Nusa Tenggara Barat yang berdiri pada tanggal 10 Mei 1981 di bawah Yayasan Pesantren Nuur Al-Azhar. Memiliki visi menjadi universitas terkemuka dalam pengembangan ilmu pengetahuan dan teknologi berwawasan kepariwisataan yang profesional dan berintegritas berdasarkan nilai Islam rahmatan lil alamin. Dengan tujuan menghasilkan lulusan berkarakter yang menguasai ilmu pengetahuan dan teknologi dengan menerapkan nilai humaniora dan Islam demi kemajuan bangsa, peradaban, dan kesejahteraan manusia. Sebuah tempat untuk mengalami proses belajar dan menempa diri dengan 7 pilihan fakultas dengan belasan program studi yang hampir seluruhnya terakreditasi baik sekali. Fakultas Ekonomi dan Bisnis, Fakultas Teknik, Fakultas Pertanian, Fakultas Hukum, Fakultas MIPA, Fakultas Kedokteran, dan Fakultas Agama Islam. Menyediakan program kelas pagi bagi para fresh graduate dan kelas sore bagi para pekerja, karyawan, dan entrepreneur. UNIZAR aktif menggelar kegiatan seminar baik skala lokal, nasional, maupun internasional. Sebuah kampus swasta dengan puluhan mitra kerjasama baik dengan lembaga pemerintah di lingkup desa, kabupaten, hingga provinsi, BUMN, BUMD, perguruan tinggi negeri dan swasta, baik di dalam maupun luar negeri, serta berbagai perusahaan dan industri. Berdiri di atas lahan seluas hampir 10 hektar, UNIZAR dilengkapi dengan berbagai fasilitas penunjang pendidikan dan penelitian. Didukung oleh dosen-dosen profesional, lulusan dalam dan luar negeri yang ahli di bidangnya, UNIZAR siap mengantarkan Anda mencapai impian dan meningkatkan karir dalam dunia kerja. Menyediakan ruang eksplorasi diri dalam berbagai unit kegiatan mahasiswa dan organisasi kemahasiswaan yang telah menghasilkan beragam prestasi mahasiswa. Senantiasa bertekad untuk menghasilkan insan yang adaptif dengan perkembangan zaman, memiliki kepekaan dalam dinamika sosial kemasyarakatan, menjadi solusi dalam berbagai permasalahan kemanusiaan sebagai wujud keimanan kepada Tuhan semesta alam yang Maha Pengasih lagi Maha Penyayang. Dengan segala dedikasi, kami siap menjadi bagian dari terwujudnya impian besar Anda. Siapkah Anda menjadi bagian dari keluarga besar Sivitas Akademika Universitas Islam Al-Azhar?
Please give a very big applause to all committee and the sponsors for today's event. Okay, ladies and gentlemen, we please the representative from Geotechnica to come forward to the stage. From Geotechnindo, I'm sorry. We please you, the representative from Geotechnindo, to come forward.
Yeah, good morning.
Okay, by online Zoom.
Okay, yeah, by online. Okay, so good morning, sir, madam, and all engineering fellow. Thank you for the opportunity. We are very honored to be part of this 5th international conference on coastal and delta areas. Okay, first of all, I would like to introduce myself. My name is Vina from Geotech Indo, a ground improvement specialist contractor in Indonesia. So yeah, let me share the screen first. Can it be seen now? Oh, sorry. Wait. Okay, is my screen visible now?
Yes, visible.
Okay. So in accordance with the topic of today's conference, we agree and are aware that Indonesia as an archipelagic country has great potential if its development in coastal areas can be maximized. However, we also need to aware that the main challenge in the development in coastal area in this topic is that we are dealing with the problematic soil, which characteristically has high water content, large soil void ratio, low shear stress, where we can generally categorize as soft soil. So for this reason, we will share briefly about our experience in overcoming soft soil problems. We Geotech Indo are...
Good job.
Okay, can I continue? Okay, so we are Geotech Indo, a branch company of the Shanghai Geoharbor Construction Group, which is specialized in reclamation, soil treatment, and soft soil treatment. Where in Shanghai, our company has become public offering company since 2021. These are our branches in the world. In Indonesia, up until now, we have carried out more than 70 soil improvement projects spread throughout Indonesia with different improvement methods, which are outlined in the following distribution maps. I will address some common problems that will be encountered if carrying out construction above the problematic soil. The common ones are sliding due to the low subgrade bearing. Like can be seen in this picture, this is the case in Sumatra Selatan, and excessive lateral deformation leading to lateral capacity failure. This usually happens at bridge abutment. And large pore settlement and differential settlement, negative skin friction, and also low lateral support. So we can mitigate the problem I mentioned before by improving the soil first before we do the construction above it. Soil improvement method can be broadly categorized into this following group. such as compaction, consolidation, grouping and mixing, and also inclusion, where these methods are chosen based on the soil type and the soil condition. So this is one of the projects we are currently undertaking. I believe many of you are familiar with this location. Yeah, this is Pantai Indah Kapuk, which is located on the coastal area of North Jakarta. So this area is currently in the stage of massive development by developer Agung Sedayu Group. This area is well promoted to be the new Jakarta city, which has the potential to become the next central business district in Jakarta. So this is the development plan. The development plan is divided into 4 areas, such as Peak 1, Peak 2, Peak 2 extension, and Peak 3. Peak 1 nowadays is well known as Gulf Island. This is a reclaimed island, and currently there is a lot of economic activity there. We compact the reclaimed sand using dynamic compaction. Apart from that, we also do fiber flotation and PVD pellet there. The total improvement area there is around 400 hectares. And now we are still carrying out the soil improvement in Peak 2 and Peak 2 extension area, which is this area was previously a fish pond. The vacuum consolidation method is applied massively in this Peak 2 and Peak 2 extension, as can be seen in the zone marked with green color is where the vacuum pelleting has been completed. So up until now, we have done about more than 700 hectares of vacuum pelleting there. The vacuum pelleting application can increase the bearing capacity, minimize pores and differential settlement, reduce the negative skin friction, and increase the excavation stability. This is the comparative picture of the condition before and after the improvement. So this is the case in South Sumatra. The soil condition is very soft. After improvement, the soil can be seen in the right picture. It can be excavated without reinforcement, just open cut. And then this is the case in Banten. The initial condition also, the ground was very soft. The excavator could hardly stand on it. But after improvement, the ground was stable enough for the excavator to stand on it and carry out the excavation. So what is the vacuum consolidation method? This vacuum consolidation method adopts 2 principles, consolidation and preloading principle, which is suitable for application on fine-grained soil. So the principle is a PVD is installed to shorten the drainage bed so that we can speed up the consolidation process, resulting in an increment of soil undersea strength. And for this pelleting, we provide a load that is greater than the design load during the soil improvement period. The purpose is to generate as large settlement as possible during the improvement period so that later on, when we lift the pelleting load and replace it with the operational load, the settlement is under control. Referring to geotechnical manuals in Indonesia, that is SNE, X460 2017, the pelleting is required to be 1.2 to 1.3 times greater than the operational design load. This is the illustration of the vacuum preloading. The improvement ground are the improvement ground area is conditioned as an airtight system by covering it with geomembrane. The PVD has been installed, is connected to the horizontal drainage system that is connected to the pump to suck out the air and the excess pore water pressure so that consolidation process can be generated. And it will generate a negative pressure, a minimum 80 kilopascal beneath the soil. This is the overview of the vacuum preloading construction method, the staging. So this is the picture of the initial condition that I mentioned before. So the initial condition is, this is a former fish pond in peak area. So the soil condition is very soft. And before we are doing soil improvement, we usually do a electric cone penetration test or CPTE to determine the condition of the soil. From the CPTE result, we know the depth of the soft soil so that we can plan the PVD installation depth. It may vary from zone to zone. And after that, if the working platform consists of a slightly hard layer, pre-drilling must be performed before the PVD installation. PVD installation using a modified excavator-based machine that has a mandrel on its wrist. The mandrel is penetrated until the depth of soft soil. And then it connected to the horizontal drainage system. In this big project, we use a sand ditch system which require a smaller volume of sand compared to the conventional sand blanket system. And on top of that, we layer the geotextile, followed by the layering of geomembrane. And the geomembrane is secure at the perimeter of the improvement area, embedded approximately around half meter below the original soil. If sand lens is found, it may cause a leakage, so we need to make slurry wall at the perimeter of the improvement area using a clay slurry mixed with this using this kind of blade. And then after that, we install geotechnical instrumentation such as settlement plate or settlement marker, inclinometers, piezometer, vacuum gauge to monitor the performance of the vacuum preloading. And then the vacuum pump is turned on. So this is the example of the monitoring result based on the vacuum gauge and settlement plate reading. So from this monitoring result, we usually do the calculation of consolidation degree using Ashoka method to evaluate whether our consolidation process has reached 90% and the vacuum pump can be turned off. So this vacuum consolidation method application in this peak area is widely used for toll road construction, high-rise building, residential, and even artificial lake. This is the photo of this existing condition. This is the road that now has been open traffic, has been operation. And this is the bridge construction also previously has been improved using vacuum preloading before the construction. And also this is the residential houses. The interesting thing is Initially, the residential houses foundation system is planned to use pile, but after improvement, no pile is used. The foundation system can change to waffle slab rough foundation. And also this is a shop and office houses that consists of 3 to 4 story houses. The foundation also can be optimized using mini pile or combined with rough foundation. And also for high-rise building, vacuum piling can save 15 to 25% of pile usage. As can be seen in the table, the lateral capacity of the pile can increase from 62 kilonewton become 307 kilonewton. It means that by vacuum piloting, the lateral capacity increased by 5 times. So it leads to cost efficiency because the pile usage can be reduced. And this is the natural lake and also the river dike and sea dike. Yeah, that's all we can share today. We hope that this presentation can be useful. Okay, thank you.
Thank you so much for the representative from Kyotekindo, and we thank you so much for supporting us in our today's event, Kyotekindo. Please give applause to Kyotekindo, everyone. Well, we are moving to photo session. The first one for offline presenters and participants. We please you everyone in this room to come forward in front of the stage, please, to have photo together. Please, all participants in this room, all guests, participants, presenters in this room, please come forward to have photo together. For online participants in Zoom, please be waiting for us. After this, we will have online photo session. And please turn on your camera. Some of you can go to the stage, please.
Provinsi atau PUPR Mataram.
Is everyone ready to take photo? The photographer, please. So everyone, please see the camera in the middle of the stage. Okay, smile. 1, 2, 3, action. One more. 1, 2, 3, smile. Okay, now for freestyle, everyone please. Okay, everyone, see the camera. 1, 2, 3, freestyle, smile. One more. 1, 2, 3. Yeah, okay, thank you everyone. Please back to your seat. Please be ready for online sessions. Photo, please everyone in online Zoom. We ask you to turn on your camera please. We will have 3 slides of photo in online Zoom. For slide 1, is it ready? For online participant, everyone please turn on the camera. Slide 1. 1, 2, 3, action, capture. Please smile everyone in the Zoom online. Okay, one more. Please be smile everyone. 1, 2, 3, action, capture. Okay, slide 2. Yeah, please everyone to turn on the camera. Yeah, 1, 2, 3, action, capture. Yeah, then one more maybe. The last slide. The last slide, please. Okay, 1, 2, 3, action. Yeah, thank you everyone for capturing the moment. Well, ladies and gentlemen, we now will have a souvenir giving. The first souvenir is from our chairman of ICCDA to the head, to the representative from Ministry of Public House and of Indonesia. We please Mr. Ari Sentani and also Mr. Nur from Ministry of Public Work and Housing to come forward. Mr. Nur? No. Oh, Mr. Rom, I'm sorry. And then we take photo together. Thank you so much.
Okay, ladies and gentlemen, the second souvenir giving is from Unisula, Engineering Faculty Dean to Rector of Universitas Islam Al-Azhar. Please welcome Mr. Rahmat Mudiono, MT, PhD, and Dr. Insinyur Muhammad Ansyar, MP. Thank you very much to Mr. Rahmat Mudiono and Dr. Insinyur Muhammad Ansyar. The third souvenir giving is from Unizar, Engineering Faculty Dean to our invited speaker. Please Mr. Lutfi STMT to Miss Hermin Pujiastuti MSI. Please come forward, Mr. Lutfi STMT and Miss Hermin Pujiastuti MSI.
Okay, thank you, Ibu Hermin and Pak Lutfi. The last souvenir will be given to the head of Pesantren Luhur Al-Azhar Foundation, and we please Prof. Imam Wahyudi to give the souvenir to Dr. Insinyur Haji Nanang Samudra, KAMSC. Okay, please give big applause to all souvenir achievers today. One more. Well, ladies and gentlemen, before we move to another agenda, that is keynote and discussion of today's event, we please you to have coffee break in front of this building for about 10 to 15 minutes. Please be back in this room again. Thank you. Bapak Ibu, kami persilakan untuk menikmati coffee break di depan ruangan ini selama 10-15 menit untuk kemudian kembali ke ruangan ini untuk melanjutkan agenda seminar. Terima kasih. Dear all participants, everyone who are outside the room, please enter the room because 5 minutes more we will start the ceremony again. Thank you. So, ladies and gentlemen, everyone, please have your seat because we will continue our agenda today. Well, everyone, dear distinguished guests and participants, dear sisters and brothers, now we are moving to discussion panel.
Ladies and gentlemen, we will have a keynote session for today, which will be chaired by General Secretary on behalf of Minister of Public Works and Housing of Indonesia.
Then we will have speech session with our invited speakers today. They are Associate Professor Dr. Kamarudin bin Haji Ahmad from University Technology Malaysia.
The second invited speaker is Associate Professor Dr. Hermin Pujiasuti, SSI, MSI from Universitas Islam Sultan Agung, Indonesia.
The next speaker is Dr. Johannes Serbeck from Universität Bremen, Germany.
The last invited speaker is Rick Heikoop from Rotterdam University of Applied Sciences, the Netherlands.
And the discussion will be led by Professor Dr. Insinyur S. Imam Wahyudi, DA. S. Imam Wahyudi, DA is a professor in hydrology. He is the initiator of Delta Center on Climate Change in Semarang. He is also a researcher in civil engineering. He gets a lot of grant from both national and international funding, including Erasmus+. And now he is the head of doctoral program in civil engineering Unisula Semarang. So everyone, please welcome Prof. Imam Wahyudi to lead the discussion.
Assalamualaikum warahmatullahi wabarakatuh. Honorable the head of province government in Nusa Tenggara Barat and rector and dean from Sultan Agung Islamic University and Islamic University of Al-Azhar, Lombok, and all presenter participant in this conference. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. In this very special occasion, that is the 5th International Conference on Coastal and Delta Area. The conference have three general topic: climate change challenge, disaster mitigation, and infrastructure in coastal and delta area. And the second topic is plan, design, and construction to develop smart infrastructure in coastal and delta area. And the third topic is policy, socio-economy, law, and multi-aspect of built environment in coastal and delta area. Actually, there are more than 100 papers submitted, and the committee select this paper, and now we have 93 paper will present in this conference, including a keynote speaker and invited speaker. And in this section, we have one keynote speaker. In this session, keynote speaker, there are no question and discussion. And then after keynote speaker, we have 4 invited speaker. Keynote speaker right now is Bapak Muhammad Zainal Fatah, who is the General Secretary of Minister Public Work and Housing, Republic Indonesia. And then 4 invited speaker. First, Associate Professor Dr. Kamarudin, who is from University Technology Malaysia. And then the second invited speaker is Associate Professor Dr. Hermin Budi Astuti. He is from Engineering Faculty, Sultan Agung Islamic University. And then the third speaker is Dr. Zuanut Herbeck, who is a lecturer in University of Bremen, Germany. And then the fourth or the last speaker is a professor from Rotterdam University Applied Sciences, the Netherlands, is Rick Heikop. Ladies and gentlemen, now let's me start from Bapak Muhammad Zainal Fatah, who is General Secretary of Minister of Public Work and Housing Indonesia. And before he presents as a keynote speaker, let me inform their curriculum vitae. Is Bapak Fatah already online now?
Yes, Pak.
Assalamualaikum, Pak Fatah.
Wabarakatuh.
Yeah,
Kita.
I know Pak Fatah because he is involved to many professional organization and many active in several organization. One of organization together with me is INASID, ya Pak Fatah, Indonesia International Commission Irrigation and Drainage. Pak Fatah will go to India next month, or no?
Hopefully, but I think I have no chance.
I will one of delegation INASID to go to India next month, Pak Fatah. Okay, Pak Fatah, I know last time he has worked in planning, development, Ministry Plan and Development in Republic Indonesia. A long time, I think, and then he also one of coordinator in this ministry, and his research staff, Ministry of Public Work and Housing, and now from 2020 he is General Secretary of Minister Public Work and Housing. Pak Fatah is graduated from Brawijaya University and then continued to Institut Teknologi Bogor and Institut Pertanian Bogor, and then he also graduated for the postgraduate from Indonesia University. This is his curriculum vitae. Ladies and gentlemen, now let me start the presentation from Public Work and Housing Ministry, Bapak Zainal Fatah. He will like to present this paper. Yeah, I think it's about regulation, implementation to develop coastal and delta area. Bapak Fatah, would you please The floor is yours.
So thank you, Professor Imam Wahyudi, colleagues, since a long years ago, as a moderator. Dear colleagues, please allow me to convey the keynote speech from Minister of Public Work and Housing on this occasion on the 5th International Conference on Coastal and Delta Areas 2023. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya. Salam kebajikan, selamat pagi, dan salam sejahtera bagi kita semua. Very good morning. Dear Excellencies, Rector of Sultan Agung Islamic University, Professor Gunarto, honorable speakers, and distinguished guests, ladies and gentlemen. It is indeed a great pleasure and an honor for me to join all of you here this morning on the 5th International Conference on Coastal and Delta Areas, initiated by Sultan Agung Islamic University. I would like to express my gratitude and appreciation to Sultan Agung Islamic University for organizing this important international conference. Distinguished guests, ladies and gentlemen, Indonesia is an archipelago country located in Southeast Asia, consisting of more than 17,000 islands. The country has a diverse geography, including coastal areas, lowland, and deltas, giving it a unique and rich ecosystem. The coastal line of Indonesia is stretching for over 108,000 kilometers, the second longest coastline in the world after Canada. The coastal areas are important, especially for the country's economy, with regard to trade, transportation, and tourism. Lowland are located in many parts of the country, including in Sumatra, Java, Kalimantan, and Papua, with an area of more than 33.4 million hectares. Their characteristics are flat or gently sloping terrain covered by dense tropical rainforest, savanna, or wetland. Lowland provide fertile areas for agriculture development to support national food security. Many of the country's major cities are in the coastal and lowland region, including Jakarta, Surabaya, Makassar, and Semarang.
Sorry, Pak Fatah. Sorry, Pak
Yes,
Fatah. Have you any slide to present? Share slide, or you on speech?
Oh, I asked to my colleagues to share with you, but let's my ask. I call.
Okay.
Okay, thank you, Pak Moderator. Please, I will continue the speech.
Yeah, please continue, Pak Fatah.
I mean, the lowland characteristics are flat or gently sloping. Like we have in many area in Sumatera, Java, Kalimantan, and Papua. So the cities like Jakarta, Surabaya, Makassar as major major cities are in the coastal and lowland area. Furthermore, deltas are formed at the river mouths, including Kapuas River, Mahakam River, Barito River, and Bengawan Solo River, the country's major rivers. Since the formation of the deltas naturally occurred over a long period of time, they are rich of biodiversity. Like the Mahakam Delta in Kalimantan has an abundant natural resource, especially oil and gases. Excellencies, ladies and gentlemen, coastal, lowland, and delta areas in Indonesia are facing a range of challenges, including pollution, overfishing, erosion, and hydrometeorological disaster. Climate change is also a growing concern, as rising sea level and changing weather patterns can have a significant impact. Consequently, it is important for Indonesia to develop sustainable practices and policies to protect these areas for future generations. Referring to the challenges on the coastal, lowland, and delta areas in Indonesia, hopefully we can get some recommendation from this conference, especially regarding on the first, plan, design, and construction to develop smart infrastructure in coastal and delta areas. The secondly, climate change challenges, disaster mitigation, and infrastructure in coastal and delta areas. Thirdly, sustainable development in coastal and delta areas. And fourthly, policy, socio-economic, law, and multi-aspect to build environment in coastal and delta areas. Ladies and gentlemen, studies, research, and development in coastal and delta areas can play a crucial role in developing innovative solutions to the complex environmental, social, and economic challenges facing this region. The studies can be subjected to the area. Like the first one is climate change adaptation. The coastal and delta areas are highly vulnerable to climate change impact, such as a sea level rise, increased storm intensity, and changes in precipitation patterns. New technologies, methodologies, and best practices are required to help communities adapt to these changes. Second, ecosystem restoration and conservation. Innovative approaches are essential to restore degraded ecosystem and conserve biodiversity, such as restoring mangrove forests, creating artificial reef, and developing sustainable fishing practices. Thirdly, for sustainable coastal and delta development, our goal is how to balance economic growth with environmental protection and social equity, such as developing sustainable tourism practices, promoting renewable energy sources, and improving waste management. In terms of integrated coastal and delta management as our common goal, the focusing on developing integrated management approach that take into account the complexity and the diversity of this system, such as developing decision support tools, decision support system, modeling system, and stakeholder engagement methods. Excellencies, ladies and gentlemen, I sincerely hope that the 5th International Conference on Coastal and Delta Areas will generate new great ideas, elaborate new initiatives needed, and promote collaborative action for a better coastal and delta development. And finally, let me also take this opportunity to invite all of you to come to Bali for the 10th World Water Forum 2024 on 18 to 24 May 2024. World Water Forum is the largest international water meeting in the water sector, co-organized by the World Water Council and the government of Indonesia. It is an essential platform to discuss global water issues, which involve all stakeholders, We will also welcome you and your family to come with you to enjoy our beautiful country. Thank you. Minister of Public Work and Housing of the Republic of Indonesia, M. Basuki Hadi Mulyono. Thank you from dear colleagues. Very good morning.
Pak Fatah. So Pak Fatah, as on behalf of Ministry of Public Work Housing, said the interest of Delta, coastal and Delta area was in the lowland and then river mouth, coastal and Delta, and we have a challenge to develop this area. Not only how to develop this area, but also by how to mitigate this area from many disaster in Indonesia. And Pak Fatah proposed how to plan and design and manage integrated coastal and delta management. And Pak Fatah informed that the next time have a great event in Indonesia, the 10 World Water Forum. Yeah, we hope can inform to the event with the Water Forum next time in Bali, I think. Thank you, Pak Fatah. We give big applause to Pak Fatah. Okay, thank you, Pak Fatah. We don't have a question for this session. We continue to invited speaker. First, Pak Kamarudin, ya. Pak Kamarudin is a lecturer civil engineering in University Technology Malaysia. His specialist is in geotechnic engineering. He was head of Department Geotechnic and Transportation, Faculty of Civil Engineering. Yeah, and I think we have some cooperation with Pak Kamarudin, and he has many publications in the curriculum vitae. Yeah, Pak Kamarudin, we would like to present Pak Kamarudin paper with the title about the geotechnical, especially in coastal and delta area in Johor. Please, Pak Kamarudin, the floor is yours.
Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good morning to Professor Dr. H. Gunarto, Rector of Universitas Islam Sultan Agung, Engineer Dr. Muhammad Anshar, Rector of Universitas Islam Al-Azhar, Dr. H. Lalu Gita Aryadi, Head Interim Governor of West Nusa Tenggara Province, Engineer Dr. Muhammad Basuki Hadi Mulyono, Minister of Public Works and Housing of Indonesia, as well as our keynote speaker today, invited speakers, paper presenters, participants, ladies and gentlemen. To begin with, I would like to congratulate the committee members of ICCDA 5 for successfully organizing this conference. I would like to express my sincere gratitude to the organizing committee for giving me the opportunity to present and share with you my experience, as well as my research team's experience in dealing with ground improvement. The title of my presentation today is Experience in Strengthening Weak Soils of Johor via Different Approaches. Please take note that the materials to be presented today are based on laboratory scale experiment. No attempts were made to employ such approaches at site. These are the members of my research team. Here is myself, Kamaruddin Ahmad. Here we have Associate Professor Dr. Nur Zurarahati Muhammad Yunus. Both of us are from University Technology Malaysia. Associate Professor Dr. Ali Dehan Banadaki from Islamic Azad University Iran, and Dr. Samila Saleh from Hasan Usman Katsina Polytechnic, Nigeria. As a well-known fact, global population growth and rapid development around the world have been forcing the authorities to provide infrastructures within their jurisdictions. As lands with appropriate engineering properties are becoming scarce, developers are forced to implement development on lands with unfavorable engineering properties such as low in strength and highly compressible. Considering the said scenarios, we embarked to study the feasibility of implementing different approaches to improve engineering properties of weak and problematic soil that could be found around us. For this presentation, we selected two types of problematic soil, namely peat and marine clay. First, let's take a look at peat. For the peat soil, we attempt to improve the bearing capacity of peat treated with deep mixing cement columns. This slide shows the map of Peninsular Malaysia and East Malaysia. So we can see the green area indicating the peatland areas. Those areas can be found along the coastal areas. Malaysia generally has about 2.6 mega hectare of peatlands, where 70% of it, or about 1.6 mega hectare of the peatlands, are situated in Sarawak. This slide shows the damages to the constructed structures which are constructed on peatland. So we can see here the supposedly horizontal beam, no more horizontal. Similarly with the stumps, no more vertical due to the settlement and due to the low bearing capacity of the peat. This picture of a house was taken in an area in Johor. This picture shows a house or a building in Sarawak. So we could see the settlement of the road compared to the the slab of the house here, and then we can see the columns no more vertical, and we can see the cracking of the floor slab. So these are the scenario that took place due to the constructed building in on peatland. Maybe I'm not saying it's correct. Maybe due to the poor ground improvement before the construction of this building. Now let's take a look at the properties of peat. Generally, peats were originated from vegetative residues. It has open cellular structure, which has inner and outer voids, high moisture content, and highly compressible, as well as low in shear strength. There are several ground improvement techniques that can be employed to increase the bearing capacity as well as to reduce the compressibility, therefore can reduce the damage to the structure constructed on the peat. So among the ground improvement techniques that can be employed are granular and prefabricated vertical drains, geotextile, and granular column reinforcement. So for our laboratory tests, we have to prepare peat soil, okay, for our physical tests. The peat we obtained from an area in Pontian, Johor. So the peat was classified as a fibrous peat with a liquid limit of approximately 280% and undrained shear strength CU about 10 kPa based on vein shear test at site. To prepare the model, air-dried peat was mixed with water amounting to 2 times liquid limit and poured into a rigid transparent tank measuring 300 mm by 200 mm and 350 mm. Then the slurry was consolidated to achieve unreduced strength of about 10 kPa. So we used the shear vane to measure the strength of the consolidated peat. Right, once the strength of 10 kPa was achieved, the consolidation process was stopped, and we move on to prepare these DCM columns. So we try to improve the bearing capacity of the pit by using DCM columns. DCM columns has been reported that it has been employed successfully in Europe and in Japan. So we attempt to use this method to improve the pit due to these geographical differences between the Asia, Malaysia, Japan, and Europe. Okay, for our DCM columns, it was constructed using peat and cement. Attempts to add filler like sand were unsuccessful because during the curing, the sand settled. So the sand was not distributed evenly in the mixture of sand, peat, and cement. That's why we decided to form this DCM column by using peat and cement only. In order to prepare the DCM columns for our physical test, we have to we perform unconfined compression tests on peat mixed with different dosages of cement in order to obtain the optimum dosage of cement to be used to form the DCM column to be used in the physical test. Okay? So we vary the dosages of cement added to the peat based on experience by Eurostep soil, okay, Eurostep soil, where they use the method of mass of cement over every cubic meter of peat. So our moisture, the moisture content of our peat was 495%. To form these DCM columns, we varies the length. There we used 3 different length over depth ratios of 0.25, 0.5, and 0.75. In addition to that, we employ 3 different improvement area ratio of alpha of 13%, 20%, and 26%. Okay, this is this slide shows the result of unconfined compression test on our trial DCM columns. Okay, the being used here 200 kilogram for every cubic meter of peat and so forth. So at the bottom here is the untreated peat. So the unconfined compression test that we perform on these samples so produce these curves. So we can see that the highest here, or the strongest DCM was due to the addition of 300 kg per cubic meter of peat. After 14 days curing period, it achieved the strength of about 170 kPa. Similarly, for those sample cured for 28 days, the strongest or the highest was also due to addition of cement, 300 kilogram per cubic meter of peat. For the 90 days curing period, we could observe that cement dosages of 300 kilogram per cubic meter peat also produce the highest strength. So based on these 3 sets of graph, we conclude that the optimum cement content or cement dosage to be used to form this DCM was based on 300 kilogram of cement for every cubic meter of peat. This slide shows the photo of the equipment used to perform the physical model test. This is the tank where the peat slurry was placed here and consolidated. This is the plate used to consolidate the peat slurry. This is the rigid footing. to apply load to the stabilized pit. This is the schematic diagram of the physical model. Here is the tank. At the bottom here, geotextile was placed to facilitate drainage during consolidation. These are the DCM columns, deep cement mixing columns. This is the rigid footing to apply load to the stabilized soil. These are the LVDTs to measure the settlement, and we have load cell to measure the load applied to the footing. This slide shows the configuration of DCM based on area ratio. So this portion here shows the area ratio, improvement area ratio of 13%, here 20%, and here is 26%. Okay, this photo shows the consolidating process of pit slurry, where the pit slurry was prepared by mixing the dry pit with the water amounting to 2 times of the liquid limit. Then after consolidation, holes were drilled using thin wall pipe with a diameter of 25 mm. Okay. So the soil inside the pipe was extruded and then mixed with cement amounting to the optimum dosage, which was 300 kilogram per cubic meter of pit, and mixed outside. Then the mixture was put into the hole. So the process was repeated for every hole. Then the DCM was secured for 24 hours before testing. So these are the columns, DCM columns, and ready for loading. The photo shows here the load cell. We have LVDTs here, LVDT here, and then the footing at the bottom here. And this picture shows the after the test, we can see the settlement of the footing due to the loading, and we can say that the failure here is due to punching shear. This slide shows the result from the test. This is the comparison between untreated pit and DCM stabilized pit. So for each graph, shows the result of similar improvement area ratio but different length of DCM over height of pit. So different ratio of length over height of pit. For this improvement area ratio of 13%, so this is for the untreated pit. This is due to the L over H 0.25. Here L over H equals to 0.5, and here L over H equal to 0.75, and this one is due to N bearing L over H equals to 1. So the same explanation for the rest of these two sets of graph. This is for improvement error ratio of 20%, and this one is for 26%. To summarize, we can tabulate the value in this table. So this is L over H, 0.25, 0.5, 0.75, and 1. And here is the improvement area ratio, 13%, 20%, and 26%. So we could see for a constant value of alpha, the ultimate bearing capacity, which was evaluated based on double tangent, the values increase as the L over H increase. For example, here alpha equal to 13%, values 70, 80, and 90. Here alpha 20%, 80, 85, 90. For 26%, 70, 85, 90. So the value of ultimate bearing capacity increase with length over depth ratio for a constant improvement area ratio. So for the conclusion, in terms of this soil stabilization of pit stabilization using deep cement mixing, the unconfined comprehensive strength of DCM columns with 300 kg of cement for every cubic meter of pit would increase the unconfined comprehensive strength of stabilized pit up to 850% compared to the untreated pit. The ultimate bearing capacity of peat stabilized with end bearing DCM columns increased with improvement area ratio. The ultimate bearing capacity of peat stabilized with floating DCM columns increased with length over depth ratio at similar improvement area ratio. Now let's move to stabilization of marine clay using polyurethane. Marine clay could be found in coastal areas, and normally this type of soil has high compressibility and low bearing capacity. In addition to that, it may experience swelling and significant swelling and shrinkage when exposed to fluctuation of moisture content due to the presence of clay minerals such as montmorillonite. The marine clay samples that used in the study were collected from the campus of University Tun Hussein on Malaysia. Just like in the case of peat, there are several methods that can be employed to improve the marine clay, especially to increase the bearing capacity and to reduce settlement. So among the methods that can be employed are granular and prefabricated vertical drains, vacuum consolidation, electrokinetics, electrochemical, deep cement mixing, and granular column reinforcement. A few tests had been conducted on clay sample. So based on the standard Proctor compaction test, this is the curve that we obtained, where we can get this the maximum dry density is about 1.44 megagram per cubic meter, or approximately 1,440 kilogram per cubic meter, with the optimum moisture content of 25%. Okay. Based on this maximum dry density and optimum moisture content, we prepare sample for UCT, and the unconfined compression strength of this clay was about 130 kPa. In addition to that, those samples also were subjected to consolidated undrained structural tests. So these are the results. So these are the curve of deviated stress against strain, and these are the Mohr circle obtained from this result. So from this result, the drawn Mohr circle, we could say that the effective cohesion here is about 23 kilopascal. Similarly, for the internal friction angle, also about 23 degrees. Now we go to polyurethane, the material that used to stabilize the soil. Polyurethane, or PU, is a polymer group with dual properties of metal and rubber that provides durability, toughness, and elasticity. Basically, it consists of two components, polyol and isocyanate. And isocyanate is volatile. So for this study, we mix these two items, or these two substances, based on 1-to-1 ratio in terms of mass. So the product of this mixture of polyol and isocyanate, which is a polyurethane, it has low density, low viscosity, short gel time, meaning it hardens very fast, high strength, and chemically inactive once hardened. This material, or this polyurethane, most effective within non-acidic or near-neutral pH environment. So the current application, widely used in building material, textile industries, and so forth. So as far as I know, this PU has been used in sand, but not much discussion been made in terms of the application of this PU in clay. Maybe because of this, the sand has a higher porosity, which permit the PU to migrate or disperse through the sand, whereas in clay, which has low permeability, very low, very difficult for this PU to migrate. So that's why not much experiment have been done on marine clay using this PU. Nevertheless, we try to use this to stabilize the marine clay that available in our area. The properties of the PU, when subjected to tensile strength test with the specimen measuring of 1 to 5 mm by 5 mm and 2 mm. This is the curve. So based on the first yield here, we approximately estimate the tensile strength of this PU was about 2 megapascal. And this is the sample of PU to be subjected to compression test, measuring about 50 mm by 50 mm by 50 mm. So this is the curve obtained from the compression test. Again, based on this first yield point here, we would approximate the compressive strength was about 1 MPa. The usage of PU for marine clay stabilization, we adopt two approaches. One is we mix marine clay with different dosages of PU, and another one, we utilize PU piles. First, let's take a look at marine clay mixed with different PU dosages. Marine clay initially had to be mixed with water at optimum moisture content. This value 25% was obtained from standard Proctor compaction test with the maximum dry density of 1.44 megagram per cubic meter, right? And the mix was kept for 24 hours for permeation before we add PU. Take note that standard Proctor compaction test on marine clay treated with PU were not conducted because of the short hardening time. Because to perform this compaction test, we had to mix the soil with PU and then put in a mold, and then we apply 27 blows of hammer, and then we put another layer and so forth. So it took time, and based on the experience, right, because of the hardening time is very short, we didn't have enough time to perform the test. So alternatively, we prepare the sample by densifying the mixture using static compression. Meaning after we mix, we put this mixture into the mold and we densify it statically using compression machine until we achieve the required density, which is equivalent to maximum dry density of 1.44 megagram per cubic meter. This is the process of preparing sample for UCT, unconfined compression test. So this is the dried clay sample, and then this is the wet sample. I mean by wet sample is clay mixed with optimum moisture content, water, and then PU was added and mixed quickly and thoroughly, and put into the cylindrical mold, and using compression machine, we densified the sample to the desired maximum, to the desired density equivalent to the maximum dry density 1.44 megagram per cubic meter. So this is the sample ready for UCT. Okay, we mix the clay sample with different dosages of PU, and then we cure at different curing period. So the percentage of PU, we varied from 4, 6, 8, 10, and 12%. And then the curing period, we vary from 1 day, 3 days, and 7 days. As we can see here, the unconfined compressive strength, KPA, against PU content, so the UCS increased as the PU content increased. Similarly, the UCS increased as the curing period increased. So this photo shows the condition of the untreated marine clay sample after the UCT. So it's bulging. In contrast, we have here a picture of a sample stabilized with PU, and then the failure shows the shear plane here. Okay. In addition to UCT, we performed consolidated undrained to the stabilized marine clay. Marine clay stabilized with PU. But for this slide, for this presentation, we only present the result from the marine clay stabilized with 8% PU. So we compare with the compare between the untreated and the marine clay treated with 8% PU. Based on these curves, we produced these Mohr circles. But take note, we only refer to the red Mohr circles and the green Mohr circles to represent the untreated marine clay and the marine clay treated with PU. So ignore the black Mohr circles and the black line. So the black Mohr circle and the black line that represent marine clay stabilized with sodium hydroxide as well as PU. But our focus here is more on untreated marine clay and the marine clay stabilized with PU. So based on this Mohr circle, the value of the effective cohesion was 23 kPa for the untreated sample, and then the internal friction angle about 23 degrees. For the marine clay stabilized with 8% polyurethane, the effective cohesion was about 68 kPa and the internal friction angle was about 31 degrees. Okay, now let's move to PU piles for marine clay stabilization. So we need to prepare this the slurry, okay, just like in the case of a pig, we the marine clay, and then we add water 2 times of its liquid limit to form slurry, and then consolidate the clay until we get the final height of the soil approximately 200 mm. So holes with diameter of 30 mm were created using thin wall pipe, just like in the case of pit. You create hole and then take out the soil. After the soil be taken out, then PU was injected into the holes. So for this study here, for the physical model here, the PU was 30 mm diameter and the spacing about 3 times diameter of the PU piles. Okay? And the improvement error ratio that we employed in our study here was 13%, but we vary the ratio of length over height. So this is the schematic diagram of these PU piles that used to stabilize the marine clay. So we can compare between the untreated marine clay without the installation of PU piles, and then we compare with the PU piles end bearing, where the L over H equals to 1, and also with a floating PU piles where the L over H equals to 0.25, L over H equals to 0.5, and L over H equals to 0.75. This is the photo showing the process of loading the PU stabilized marine clay. So this slide shows the result from the physical model test. So for the solid line here represent the untreated clay. This is for the L over H 0.25, and then L over H equals to 0.5 here. And the triangle here represent the L over H equals to 0.75, and this circle here represents the L over H equals to 1. So to summarize the values here, based on this double tangent, so approximately the ultimate bearing capacity for the marine clay without PU pile, the bearing capacity, ultimate bearing capacity about 35 kPa. Marine clay with PU pile with L over H 0.25, 60. Marine clay with PU pile with length over height ratio 0.5, we got 90. Marine clay plus PU pile with L over H ratio 0.75, we got 100 kPa, and MC plus PU pile and bearing, the value that we get is 120 kPa. So as we can see here, the value of ultimate bearing capacity increased with length over depth ratio. So as a conclusion for these marine clay stabilized with PU piles, unconfined compressive strength of marine clay increased with PU dosages. Right? There's no optimum because we limit the dosages of PU from 2 up to 5% only. But from the graph, from the result, we could see that the trend of the strength increased with dosages of PU. Second improvement in terms of strength was due to densification and coating of marine clay particles with PU foam. Mixing PU to marine clay increased the values of cohesion and internal friction angle by 200% and 35% respectively. And bearing capacity of marine clay stabilized with PU piles increased with increase in length over height ratio compared to the untreated marine clay. With that, I end my presentation. Thank you.
Thank you, Dr. Kamarudin. Let me summarize Pak Kamarudin presentation. Pak Kamarudin have research first about weak soil, tanah lunak, especially peak soil, ya, gambut, and he has make experience in laboratory. Make a correlation between vertical stress and displacement, yeah, for the peak soil, and they use innovation using column method to better ground stabilization. And the second one, Pak Kamarudin explained research about the clay marine, ya, tanah liat untuk yang di marine, ya, di pantai. Pak Kamarudin use additive polyuretan, ya, polyuretan or PU, ya, PU abbreviation, ya, polyuretan, and Pak Kamarudin and team search how the optimal composition PU to put in the composition of clay marine, clay soil marine. Okay, nice presentation, Pak Dr. Kamarudin. Applause to Pak Kamarudin. And the question is, after all presentation, invited the speaker. And let me call to the second invited speaker, Ibu Dr. Hermin Puji Astuti. Please, Bu Hermin, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector Universitas Islam Sultan Agung, the Honorable Bapak Dr. Insinyur Ansar, Rector of Universitas Islam Al-Azhar. Good morning, ladies and gentlemen. I would like to thank you for coming in International Conference of Coastal and Delta Area in this morning, and an honor to meet you in here. Let me introduce myself. My name is Hermin Puji Astuti. I'm from Universitas Islam Sultan Agung, Department of Civil Engineering. Let me present of our conclusion is from my research. My presentation is entitled of the prediction of hydrological drought index, or HDI, based on rain simulation data using artificial neural network. Okay, next slide, please. My presentation consists of my following parts. Number one is the first is the introduction, and the third, the second maybe, the forecasting and measuring drought, and the third is the methodology, and the fourth is in the discussion, and then the last is the conclusion. I would like to introduce my guardian here. We know the water is necessary to our more sustainable of human development, and for the healthy and the function of the planet ecosystem. The problem of this water is worse. If the waters in the area is too much, this is the result of the flood. And then for the quantity, and if the water is the quality of the dirty, this came to water quality problem. And then the third is if water is too little in the area, this can cause the drought. If the today drought is a common feature in its coexistence process, if the potential of threat which cannot be eradicated, but so there's to be management. Drought is we can do the three classification or four classification. There's a meteorological drought, and then hydrological drought, and agronomical drought, and then social-economical drought. The fourth of the classification of drought is can be the problem of the scarcity of the water. And now I would like to look at the different, the next please, of the kind of the drought event. If the meteorological drought, this is based of the the dryness of the rainfall, of the define and length of the dry period. And then the agricultural drought, this is impact of the agriculture from the factor such as things of deficit, soil water define and reduce, and the groundwater or reservoir level is decreased. And then the hydrological drought, this is based on the impact of rainfall deficit on the water supply, such as the stream flow, and then the reservoir and lake level groundwater table decline. And then the third of the about the meteorological drought, agricultural drought, and then hydrological drought. It is the water scarcity, and this the social impact and the complexities of the water problem. The next, please. The problem of the drought and can cause of the variety of the problem. This to local community or including damage of the ecosystem, crop, and shortage of the drinking water. We know that drought is a repeat of the natural cycle. This is an influence by the global climate, and then the phenomena of the El Nino Southern Oscillation, or ENSO, in the Pacific Ocean, and then Indian Ocean Dipole, or IUD, in the Indian Ocean. And out the drought and the similar of the water scarcity, there's a water scarcity we know is the triggered by drought, but mainly the water scarcity is mainly because of the anthropogenic human factors. This is exercise, excessive water usage, and damage the environment. The next agenda is this. We applied about the drought is forecasting, and that can be measuring about the drought. Because the quantification of the hydrological drought especially is the crucial of the effective drought, one of the crucial of effective the management of the water. And then even though the scientists are unable to predict how long the drought will become and last, or how severe it will be, and then one of the efforts is the early warning system and monitoring tool. We can minimize some of drought damaging impact. And this is include detecting past drought and forecasting drought in the future. And to assess past drought occurrence, and then to identify and track current drought, and to the forecast future drought. Drought index is inquired, one of the required to focus on measuring of the drought. Some of the research is show that the hydrological index is a base of the measuring based the discharge calculation using the MOG method, and meanwhile this is indicated that drought sharpens indicator based on the discharge has a good level of the reliability. This may be there are number two of the another drought occurs, and due to the limitation of its system. There's data from the different sources, and often compiled to create a more comprehensive to forecast them. And then now we would like to show this is one of the tool of the draft index, draft index. Draft index or draft index, there's a number of indication to the magnitude of the draft. This is similar of the Richter scale in the measurement of the Kappa is this one index of the earthquake strength. The index or index draft is based on the theory of land, and if the index value is negative, there's indicating the draft. And especially in the hydrological, meteorological, or agronomical draft, this is cancelled from the measuring of the index. And one of the application of the measuring of the index draft, we are now showed the one of the application is to forecast or measuring the drought prone location in Rembang Regency. The next slide, please. Yes. This is of methodology. Yes, this is of the one of the application to measuring or forecasting hydrological drought index that can be applied to one of the region and Central Java province, especially in Rembang Regency. One of the watershed, I'm sorry, this is incorrect name of the watershed. This is Randu Gunting watershed, not the Karanggeneng, I'm sorry. Why we applicable in this area? Because Rembang Regency, especially in one of the area in the north of Central Java province, there's the characteristic from in the south area is the built from the North Limestone Mountain, and then in the north area, this is from the coastal area, lowland area, and then highland area, and south the mountain in the limestone. The main of the Randu Gunting area, or the Randu Gunting watershed, this is main river is the Randu Gunting river. The problem of the river Randu Gunting, there's a flow is river's flow. This is an erratic and the subject to the fluctuating over the time. If it is the responsible to is an forestation, natural, the occurrences, the occurrences. The first discharge in the Randu Gunting River, this is rises during rainy water, while there's falling through in the dry season. There will be drought threats in various places when the extended dry season starts, and then cause the raw water in this area is insufficient available. To forecasting and calculation with applying the index, we required some of the data. The data requires included from the rainfall data from the 3 station rain station, namely in the Kaliori, the second is the Sumber station, and the third is the Bulu station of the 12 years period from 2011 to 2022. And then the second is we collect the climatology data from the Tempuran Reservoir Climatology Observation Station in the near of the Rembang Regency. It is the Blora Regency of the last year from 2014 till 2022. And then from this locating is we need the Indonesian earth map and hydrological map, and then the land use map. Some of the software we get the MATLAB, ArcGIS, and the Microsoft Excel. The next, this is encourage the data analysis from this data we collect. The first is to homogeneity test from the data, especially is data heterology, because the data heterology is one of the data we can collect is for the time series of this data. This is to availability can to good and quality discharge data. And then localized rain, we applied this to show the area rain, or we choose this the Thyssen method. And then the second the next, yeah. This is the simulation of the rain calculation. We applied of one of the artificial intelligence. This is artificial neural network, or INN, with back propagation algorithm. And then to simulate monthly discharge, we choose the FGMOC to appropriate the monthly discharge because the calculation of the hydrological index is the simulation from discharge data. So this is simulated discharge from the base of the rainfall data. And then the mainstay discharge and the normal discharge use the ranking, the approach. We choose the Weibull formula to determine rate predominant discharge, or Q80, and the normal discharge, or Q40, based on the discharge data requirement. And then the calculation of the next threshold. This is threshold calculating, and the threshold is show what's the limit value of the establishing of the accordance with analysis requirement. And then to detect of the deficit or dry duration, this discharge value obtained from the simulation discharge from the FGMOC. This calculation using this technique. And then our degree of the severity of drought based on the HDI, or hydrological drought index. This is for classification. When the Q8 and is called as dry, or symbolized with D, if condition the Q8, the Q is from the Q40 till Q60, 80. And if the cold very dry, or symbolized with VG, if the 21% till 100%, if the include is the Q80. And then if we call very, very dry, or symbolized with VVG, if the Q discharge is less than 70% of the Q80. And then it's called wet, or symbolized as the W, if the discharge is more than Q50, or the normal condition. The next, from of the analysis, we can show what condition if the Randu Gunting water set. This is a show about the recapitulation of the monthly average rainfall, such as the millimeter, using the Thiessen method. This we can show this from the March and November, the average of the rainfall is in minimized, yeah, using the Thiessen method. And then the next slide, we can show that the next slide, please. Yeah. This is a part of the artificial neural network method to draft prediction analysis. We see the 10 four states of the rainfall prediction. From the data collecting in the 12th period, this is part of the input, yeah, and then the process of the network training and the output of this process. The input, we make the data and the pattern determination, and 1/3 for input training. We part of the data from years 2011 till 2015. And then 1/3 for target training, years from 2015 till 2018. And then the 1/3 for observation and from years to 2019 till 2022. And then the network training, for the training is we get from the 144 data. This part of the row is the 12th row, and this the column is the 12th, and the can makes the matrix as the 12 point 12. From the application of NNN method, this outcome of the simulation, this figure is the result of the simulation with the INN. This is a simulation result of the mainly rainfall in the Randugunting watershed from 3 rain stations, Kaliori, Sumber, and the Blue rain station. The outcome of the simulation forecast and the refrain are quite similar. In the line chart, the black line, this is represent a simulated rainfall from the application of the INN, and then the bar chart is represent a graph at historical rainfall or actual rainfall. Okay, and the next place is there is so that the outcome is the very similar, not the very along of the similar allowing, and the simulated discharge of the monthly of the FGMOC method. There's we get classification about this discharge. Yeah, we got for the Weibull normal discharge formula. When the Q50 as the threshold for determining of the visit value and dependable discharge to determine the degree of drop using HDI method can be derived based on the result of the MOC method. And the recapitulation of monthly simulated discharge MOC method, there's we can the 4 years from the especially at the 2023 until 2026, and the threshold graph, the next slide please, from the 4 situation from the 2023 till 2026, the according this figure, the land chart represent simulated rainfall, and from the 2026, 23 till 2026. And for the line of orange line is the normal condition or Q 50. We can describe, for example, in the condition of 2023, there's from the April or May, April and October, this is a condition of the deficit, and from the November till April is the condition of the below of the Q50. And then from this, the next please, about the condition, we can describe of the condition, the deficit or the dry duration. From the calculation, the deficit each year is carried out by reducing of the discharge by this threshold. This is discard will be obtained using the surplus of deficit criteria when as the deduction, and then deficit periods draft respectively on 2023 till 2026 are listed below. This from the calculation of the deficit or deficit duration, the condition. And the determination of the hydrological draft event from this criteria. From this table, we can show that in Radu Gunting, there's a recapitulation. The condition of the dry criteria from wet condition and dry condition, very dry condition, or till very, very dry condition. There's the VVD or the very, very dry condition decrease of drought, especially from 2023 till 2024, occurring once it's even. And even with the very dry is decrease if drought, it will happen once it the 2023 till 2024. This is mostly of the Randu Gunting. There's this condition of the wet, and the months that are prone to drought is in March till November. Okay, there's a conclusion about the application of the INN in the Randu Gunting area. Applicable for the method, this INN can be used as an effective tool for the prediction of hydrological drought index, and can also based in the other fields to improve understanding drought occurrence trend. And the second, since the result of the simulated rain forecast and the actual rain are relatively comparable, further computation can be made using the rain prediction data output result. And the third, the results of this analysis show that the drought index and drought sharpness of index from 2023 till 2026 experiences normal or wet condition are decreasing from 7 months in 2023 and 2024 to 6 months in 2025 and only 3 months in 2026. And then the last, the prediction of drought, and this is in 2023 to 2026 will be dry for 15 months, very dry for 8 months and very dry for 3 months. And the examination of the hydrological draft index of the hydrological draft duration pre-craft that the typical draft period still between from May to November. Ladies and gentlemen, this is the last of my presentation. Thank you from this, and Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bu Hermin. Let me summarize 1 minute her presentation. And I forget to say your curriculum vitae, Bu Hermin. Yeah? Bu Hermin now she is associate professor in engineering faculty of Sultan Agung Islamic University. She graduated from bachelor, master, and doctor program in Gajah Mada University. Yeah? She is very consistent to learn in one university. Yeah? Gajah Mada University. Okay, Bu Hermin say about the drought, kekeringan. We know that in the coastal and delta area, the problem is not only flooding, yeah, not only banjir, but also drought. And Bu Hermin have a case study in Rembang, yeah, Rembang Regency, central of Java, especially in the west of Rembang, ya, Randu Gunting, catchment area. And we mean view the drought nature of meteorology, agriculture, and hydrology, and we mean have many analyses to forecast. Prediction, ya, ramalan, perencanaan untuk for drought, and how to anticipate, ya, how to mitigate drought in this area using artificial neural network or ENN, and using hydrological drought index. Yeah. One again, applause to Bu Hermin. Thank you, Bu Hermin. And now we arrive in the third invited speaker, my colleague from Germany, Dr. Johannes Herbeck. Good morning, Johannes. What time in Germany right now?
It's 6:15 in the morning. Good morning. Selamat pagi.
Yeah, it's a very early morning in Germany, and Johannes Herbeck is one of experts from Germany who has cooperated with Sultan Agung University and also Indonesia University. Let's me say his curriculum vitae. Dr. Johannes Herbeck is a lecturer in Bremen University, Germany. He is a senior researcher with focus on climate change and mobility in Sustainability Research Center, Bremen. And is a doctor of philosophy in geography, also in University of Bremen. So he continue work in University of Bremen as a lecturer, and he has many publication and many research, and also many case study research is in Indonesia. Yeah? Johannes Herbeck. Okay. Please, Johannes, the time it's yours for your presentation. Please.
Yes. Good morning. Can you hear me?
Yes.
Yes. Okay. So, very good morning again from my side. Selamat pagi, and thank you very much for this kind introduction, Professor Imam. I'm really honored to be invited to this panel, this opening panel of the International Conference on Coastal and Delta Areas. And it's a pity that I cannot be here physically, but I try my best to deliver my speech also in this virtual format. So thanks again for organizing this, for inviting me to this event, and for having me on this very high-ranking panel. So I'm really honored to be able to speak to you this morning. As Prof. Imam has already mentioned, I come from a slightly different disciplinary background than probably many of you. I have a background in social sciences, in human geography. So I've been trained as human geographer at the University of Munich, the Technical University of Munich, and have continued since then to do research in projects with a clear social science focus. I have applied different methods that come from the social sciences, quantitative methods in the form of larger questionnaires, but also qualitative research, interviews, qualitative data analysis, and many other things. And for this reason, I thought that I would also give a slightly different presentation today, also taking you along to the most recent research we've been doing also in Indonesia in the context of a DFG project, the German Research Foundation that funded a research project over the past years. So I've entitled my talk, Experiments of Sea Level Change Adaptation, How Can Social Sciences Contribute to Understanding Types and Impacts? So the focus on experiments has been one that has kind of emerged in the during the carrying out our research projects, because we started with, and I will show you in a minute, we started with focusing on certain technologies and their distribution, their spatial distribution in a rather global setup. But what we found was that besides this focus on the very concrete technologies, that there are many different kinds of experiments that are taking place at many places around the world that deal with the question of sea level change adaptation. And I think we've already seen some of those experiments in the talks today, the very experimental ways of thinking about, for example, forecasting droughts, also working with materials like peat and seabed sediments and their compaction. So those experiments are ongoing, and some of them are also really targeted towards sea level change adaptation. And our attempt was then also to try to understand how can we kind of classify those different kinds of experiments, what types of experiments can we see when looking at those places, and what are then potential challenges and impacts of those different kinds of experiments. So to show you a little bit more about the project context, as I said, I have been working together with colleagues and partners, among them also my colleague Rapti Siriwardana from the Leibniz Center for Tropical Marine Research, also here in Bremen, but also colleagues like Professor Imam from Unisula and colleagues from the Universitas Indonesia, which have strongly supported our research in Indonesia. We've been working on a project that has been called Blue Urban, and that tried to analyze global networks of adaptation innovations or technologies or knowledges in a rather, as I already said, in a rather global approach, trying to follow them from different sides that you see here on the right-hand side. We've called them sites of innovation, with which we mean, for example, university groups, laboratories that research or develop ideas around sea level change adaptation. We've looked at or tried to look at sites of circulation, which we originally thought would be conferences or science fairs, where people are talking about those different approaches or new approaches of dealing with sea level change. And finally, then sites of adaptation, where we wanted to look at the actual implementation of those new ideas in the form of projects. And we've concentrated our work on two very distinct technologies that we had identified before, kind of emerging technologies of sea level change adaptation that had been heavily debated and continue to be debated when we wrote the project. And the first would be multifunctional dikes, sometimes also called super dikes, or the distinction is not so easy, at least between those two forms of diking. And the second technology was floating structures or artificial islands. And with those two technologies, we also moved along, I would say, two poles of a spectrum between very protective forms of dealing with sea level change, like through diking, for example, but then moving also to more embracing and more hybridized forms of also living with waters and accommodating for changing sea levels through the introduction of floating structures. So that was the rough setup, and now I'm going to concentrate probably a bit on the last kind of sites, namely the sites of adaptation, looking at the concrete implementation of some of those ideas at some places. And I'm also trying to focus on some of the areas that we ended up looking at, namely places in North Java, where you can say that some of those places are, of course, or can be considered to be frontiering submergence at sometimes very high rates due to, of course, subsidence. I don't have to tell you that. You probably all know that very much better than I do. But those places obviously are experiencing sea level change at rates that are sometimes very high, up to 10 or 15 centimeters per year. That kind of already experience now what could be considered to be the future of many other places if sea level change rates due to climate change develop according to the projections. So, and this is not only happening, of course, in northern Java. This is a photo that I took in Tokyo at a place that had been experiencing subsidence at similarly high rates as, for example, Jakarta Fluid, or also places in Semarang, Pekalongan, or others, where those very high rates of subsidence are currently occurring. And this pole here marks some of the markings here. The rings represent earlier ground levels. I think the highest one here is the highest ever recorded high water mark that has been experienced by the deltaic river close by to this area, which also shows, of course, the high potential vulnerability to flooding events. And those trends can be also seen in this graph here that shows the total amount of subsidence that some cities in Southeast and also East Asia have been experiencing or are experiencing at the moment. Cities like Manila and Bangkok, Taipei, that have slightly less impact of subsidence. But then, as I mentioned, the cities in Japan, Tokyo, and also Osaka that have started at a much earlier point in time, already in the 1920s, but at very similar rates like the ones that you observe now for Jakarta Fluid, for example, marked here in red. It is also clear that there are measures that can stop subsidence very quickly, as you see for Osaka and Tokyo, that by taking serious measures of, for example, stopping groundwater extension, had been able to stop subsidence within a couple of years, or even a month after those measures had been taken. So while you can say that there are places that are frontiering subsidence, we think that traveling to the region also shows that we also see places that are frontiering experimentation. Of course, with those very rapid changes, sometimes in sea level change, there have to be measures that are developed, and you find very active scene of scholars, of researchers that do experiment with potential answers to those problems. So the picture on the left is the pond behind Unisula Civil Engineering faculty. Many of you know this place, and there are experiments ongoing with different kinds of materials that can be used for floating infrastructures, for platoon infrastructures that can accommodate for sea level change. Sea level changes. In the middle is a scholar from Trisakti University that also experiments. She also experiments with different forms of materialities of floating infrastructures and combines them also with more traditional architectures that are put on top. But the base of it, it's not really visible here, is by using blue barrels, put them together, and thereby create a floating platform. After seeing this, we thought, okay, those experiments are really an interesting thing to look at, seeing that those affected sites, cities, are then also key sites of those adaptation experiments, and they also change between those different forms, the more amphibious or terra-aqueous forms of adaptation, and the protective forms of coastal infrastructuration that can be taken as potential ways to solve those problems. We quickly realized that the knowledge networks that are behind such experiments are crucial then also for understanding how on a very local level those trajectories of learning and knowledge production work. So with whom are those scholars that work on those adaptation experiments, with whom are they collaborating, where are also exchanges of knowledges between the different groups, and how do those networks work? This is something that we thought is quite crucial. And we also thought, of course, then there are also very different forms of experimentation that we can observe, and we try to classify them into three points. The first would be more paradigmatic or disciplinary forms of experimentation. The second would be material experimentation, and the third, I don't know why it says fourth here, the third would be governance experimentation. And I'm going to come back to those different forms now for the rest of my talk a bit. And I will also now try to bring you to some of the concrete implementation projects that we've been looking at. And one of them was the multifunctional dike in Semarang. To my knowledge, the first dike in the region that has been termed multifunctional. So this is a rough sketch from one of the project documents. the construction is already ongoing, and it is carried out in different phases. The first phase being already implemented, in the second phase, and that's also something that probably some of you know even better than I do, is in the moment carried out. So, and naming it a multifunctional dike then also grasped quite a bit of attention also on the national level, with President Jokowi being present, for example, at the ground laying ceremony in 21. When you look into some of the project documents and the planning documents behind the multifunctional dike in Semarang, you see that already here there's quite a bit of a very fundamental changes that are, I mean, at least at this stage have been envisioned. The project aims at transforming ongoing single-purpose infrastructure projects like the planned Harbour Toll Road that had been planned before, to infrastructure with water capturing and storage functions. The program creates win-win situations for both public and private sectors by transforming grey infrastructure to multifunctional green infrastructure. So on different levels, an integration of different functions into one infrastructural solution. So bringing in a water capturing, water storage, also thinking about how to add a green infrastructure thinking into this multifunctional dike, and also bringing in different actors. So creating win-win situations for both public and private sectors. So by, for example, establishing new industrial reservoirs behind the dike and something like that. And this multifunctionality then also, of course, impacts on the way how the team has been composed. This is a photograph that I took, or that was taken during an interview with the toll road team at POPR, and the composition of the team also reflected some of the thoughts or some of the reason why we classified it as also as a disciplinary experiment, because of course when adding those different functions to the scheme, you also need a broader range of disciplines that work on those issues. So of course there were civil engineers that were working on the issue, but there were also hydrologists that were brought in. Of course, also road construction companies, then geologists that worked on the kind of foundational sediments on which the toll road or the multifunctional dike would have been established, in something like that. So an abundance of disciplines that had to be brought together to work on this project. And of course, as probably also some of you know, creating those multidisciplinary teams poses certain challenges also to first establish a joint language, for example, very basic things. The multifunctional dike in Semarang, of course, is not the only dike in the region, in the wider region, and also a travel to Tokyo in the course of the project. We also visited some of the multifunctional dikes that have been continuously built. I mean, it's also already since a couple of decades, actually. I think the so-called super levee project for Tokyo already started in the late 80s, and you see also a bit similarly to the former project that I showed, the adding of different functions into one protective infrastructure also has been quite an important aspect of Tokyo super levees project, especially regarding also the reorganization of housing on top and behind the dike, which of course then also meant quite a fundamental change of the coastal space in those respective areas. another function that has always been thought of and considered in constructing those super levees was also open spaces that could be used for evacuation purposes, as they're shown here, for different reasons. Of course, also the earthquake aspects that always play a role, of course, also in Japan. And this is for parts of the Arakawa Kaiyo River that runs through Tokyo, but is of course also connected to the open sea and brings then also storm surges into the city. And what is the impact of those super levee projects? This is a photograph that I took there at the very end of such a super levee project, and what you see here. Sorry, going back, what you see here are those, on a very small scale, those high differences. This would be the area that is out of the super levee, that is still on the same ground level as this places used to be. And of course, it also creates certain challenges and differences between city quarters on very small scales. The second technology, as I've mentioned, that we looked at was the idea of building on water, floating infrastructures, and on a global level, you can also see that there are discourses to move from older amphibious vernacular architecture, for example, stilted houses, to more buoyant forms of building on water, including also semi-mobile building. And UN Habitat plays an important role here that endorses the idea of floating cities and hails them as a metaphor of civilizational adaptation, as a corrective to also destructive land reclamation practices and artificial islands, and also a localized anti-eviction strategy for heavily subsiding regions. So there's a lot of hope that are put into those experiments with floating designs on this very disciplinary or foundational level. So for the question of material experimentation, I think I don't have to spend too much time here, because I mean, most of you probably a lot of you work on those very material experimentations, and we've already seen this in the earlier presentations. When it comes to the multifunctional dike, working with bamboo, for example, has been one novel way of approaching or laying a foundation of a dike, and this has been quite interesting for us. Also, the man in the middle has been the bamboo expert, looking at also different varieties of bamboo and how they can be used for consolidating the ground that is still will continue to compact once the dike has been finalized. What we also found interesting, that on the construction site itself, the bamboo material has been also displayed, which also on those displays, which also led us to the conclusion that, of course, also the construction site could be also a place of circulation, where some of those material experimentations are also shown and explained and passed on to people who are visiting this experimental site, obviously. Yeah? And the mobility behind it, that has also always been one of our foci, also came clear when talking to the Toro team members. And they said, yeah, of course, we've talked to the team of Changi Airport in Singapore. We had meetings with South Korea and Australia, but the project here is the biggest, and we do use very local materials. We experiment with different bamboo varieties, all are from Central Java. So working with bamboo and working with those different kinds of materials also opened up a certain network of people that had experiences with this before. Material experimentations, and some of you are working with it, I know, with regards to floating infrastructures, is also something that we looked at. My colleague Rapti, especially, she went, for example, to the B-Foam company, a homegrown Indonesian company that uses recycled styrofoam, and experiments with recycling styrofoam for flood and earthquake proofing. And the managing director told my colleague, some people who told us to use styrofoam made from cassava, but we will not, since that's biodegradable and the structure can be gone in 3 years, so we don't want this to be biodegradable. That's our limitation. We're not trying to put a lipstick on a pig, but at least we will not make any more pigs again by using, obviously, those recycled materials that have been then, for example, also used for the floating library in Tambak Lorok in Semarang. So let me quickly come to the last form that we've kind of identified, the governance experimentation. And with this, I would also like to bring you to a multifunctional dike in the Netherlands, in Katwijk aan Zee. Please excuse me if I'm not pronouncing it right. It is on the left-hand side. There are also other examples in the Netherlands where multifunctionality has been one of the design principles in coastal infrastructures. The right-hand side is the Scheveningen Boulevard, that also includes different kinds of, for example, also tourist functions into the dike. The example on the left-hand side, the Katwijk aan Zee, has been one of the experimental setups where some of those ideas around multifunctionality have been studied and tried out. And when talking to some of the involved people here from the TARIS, for example, they also show the challenges that also come along with those, with integrating different functions into one infrastructure. If you look at the process, how this parking garage was created, it's a drama. Really, at the beginning, there was no trust between the regional water authority and the municipality. They were like cats and dogs. At the end, the regional water authority parts of the parking garage, but still there's difficulties about who is responsible for what. And that's in a way also logic then, that if you include different functions into an infrastructure, that also brings along different responsibilities, different actors that have not been used to working together before. And those are some of the governance challenges that come along with those experimentations. I think I'll skip that. Again, for the Semarang case, also the political territoriality behind the dike is kind of interesting, also showing that to some regard the location of the dike also tries to re-establish a former coastline, of course, given that the coastline has been retreating over the past centuries, sometimes a couple of kilometers inland, and putting now the dike in front of the area also tries to, at least to a certain extent, also re-establish those older coastlines that used to be, for example, in the 1980s or 90s. So it's also about fixing those old coastlines with the use of the dike. And this then, of course, also creates obvious conflicts between different forms of territorial claims to those lands that have submerged in the past decades and where people still have, to a certain extent, ownership. And those then, of course, also touches questions of compensation of land that has now been submerged, where in some areas it's not clear who really owns land, and there have been also transfers of land in the past years, and so quite a sometimes kind of messy situation on the ground that is, but then also reflected, like those old territorial claims are also reflected through people still continuing working on those areas and putting up those bamboo fences for trapping fish and so on. Yeah, I mean, to come to a quick conclusion, I think, or I hope I've been able to show that there are different forms of experimentation that sometimes then also, of course, also interact and contribute to local learning trajectories. The combination of transnational knowledge production with local experimentation is something that has been quite fascinating to see. And sometimes it's also, of course, not easy to disentangle what kinds of knowledges really have went into then those very concrete implementation of projects. I hope I've also been able to show that those different types of experimentation that we've tried to classify bring along very distinct challenges and conflicts or potential conflicts. Challenges, as I said, finding a joint language in those disciplinary experimentations, conflicts when thinking about those different territorial claims in submerged lands and the and their open, I mean, breakout of conflicts then in the case of implementation of projects. So I would like to end with experimentation also, of course, and sounds very future fixed, but we think that experimentation can also be about looking into the past. One aspect that I've mentioned was the reaffirmation of fixed boundaries via diking, but also thinking about novel ways of retrofitting the more traditional amphibious design that we've seen at other places. And with this, I would like to end and thank you very much for your attention.
Thank you, Johannes. Applause to Dr. Johannes Herbeck. Yeah, let me summarize 1 minute his presentation. Dr. Johannes Herbeck and team, Rapti and other researchers from University of Bremen have experiment in climate change adaptation, especially for the problem of land subsidence and sea level rise, penurunan tanah, and kenaikan muka air laut. And they have some case study in north of Central Java, Semarang, Pekalongan, Jakarta as well, and comparing with other location in the world, like as Tokyo and other city in European. And the focus of their technology is multifunction dike and floating structure. And Dr. Johannes Herbeck have another view how to adapt climate change, not only in technical solution, but also social and communication. Yeah, his focus is social and communication, how to communicate the government, the community, and other stakeholders. Yeah, to implement that technical solution, and they understand about the innovation first, and then communication circulation, and finally how to adaptation process. Yeah, this is the focus research Dr. Johannes Herbeck. Let's applause again to Dr. Johannes Herbeck. Okay, we arrived to the last invited speaker. He's Rick Haykop. Rick Haykop is from Rotterdam University, Applied Sciences, the Netherlands, and his student is here in this conference, Tom and Lillian, and also will present this afternoon. Rick have a long time cooperation with Sultan Agong Islamic University, with me, Bu Heni, and other colleague from Sultan Agong Islamic University. We have research about climate change, water management, along of north of Central Java, and also we have several together publication together between Unisula and Rotterdam University Applied Sciences. Let's Rick Haykop present your presentation, and Rick Haykop, the time is yours. Please.
Hello, Pak Imam.
Hello,
Thank you for the
Rick Haikop.
introduction.
Yeah.
I'm very honored to be here today. Actually, I prepared a presentation. I don't know if I should upload it myself or the organization can do that for me.
You will present his video or directly Pak Ari? The chairman asked me you present directly, and
Okay.
yeah, this one is more excited. Please,
Okay.
Rick.
I'm sorry, I have to look for the file.
Yeah. Pak Ari, we have also his file. Okay. So please continue, Pak Ari.
Sorry, there's a
We see your slides. And you're still muted, I think.
Since 2012, we exchange students, staff. I would like to thank especially my friends, Dr. Kamarudin, talk today about climate change, adaptation, show some examples of how we integrate climate.
Yeah. Okay. I think Rick Haikop have a problem connection maybe. So let's use video record to present their present, and then after that we discuss directly with Professor Rick Haikop. Please committee to present their his video.
Selamat pagi, nama saya Rick Haikop. Saya dari Belanda. Saya bekerja the Rotterdam University of Applied Sciences. This is how far my Bahasa goes, so I will continue in English. I would like to thank Bapak Ari Sentani, Chairman of the 5th INDA Conference, and Professor Dr. Gunarto Hum, Rector of Universitas Islam Sultan Agung, and the honorable guests and speakers of this morning. Rotterdam University of Applied Sciences and Unisula University collaborate since 2010 on delta management. Since 2012, we exchange students and staff and we collaborate intensively. I would like to thank especially my friends Dr. Iman Wayudi and Dr. Henny Prativi Adi from Unisula University for our ongoing friendship and collaboration. My talk today is about climate change and adaptation education. I will show some examples and how we integrate climate adaptation in the curriculum at Rotterdam University of Applied Sciences. As you can see, I'm not here in Lombok with you. I decided not to take the airplane today so that I was able to save 4.1 ton of CO2 emission for my round trip Amsterdam to Lombok. 4.1 ton CO2 is almost double the 2.3 ton emission of the average Indonesian person. And it is about half of my annual emissions as a resident of the Netherlands. So we should all contribute to reduce our CO2 emission, but unfortunately, as a result, I'm sitting here at home and I cannot join you at this interesting conference. I cannot listen to your inspiring presentations, and I can also not enjoy your beautiful island of Lombok. According to the IPCC Synthesis Report of 2023, human activities, principally through the emissions of greenhouse gases, have caused global warming, as we all know. Global surface temperatures reaching 1.1 degrees Celsius above pre-industrial times. Human-caused climate change is already affecting many weather and climate extremes in every region across the globe, as we see every day on our television. Vulnerable communities who have historically contributed the least to climate change are disproportionately affected. If we look at the red circle in the presentation, we see that the global temperature continues to rise, and the hottest day temperature in your country can be 7 degrees higher than today if CO2 emissions continue to rise. Delta areas located on low-lying coastal areas and delta cities are extremely vulnerable for the effects of climate change. Different calculations are made about the number of people living in coastal and delta areas. According to a calculation by the United Nations in 2021, it was estimated that by the year 2030, about 50% of the world's population will live in coastal areas which are exposed to flooding, storms, and tsunamis. Countries like Bangladesh, as we see on this picture, are extremely vulnerable. In 2050, with a world population of 9.7 billion, almost 5 billion people could be living in vulnerable, low-lying coastal areas. In my country, the Netherlands, last week was the warmest September night ever recorded in history. In Indonesia, you have your fair share of floods and disasters as well. Some of them are related to climate change, others are not. We watch the news and we all know the facts. But the world is watching at us, the scientists, the academe, and the industries. What should we do? And what isn't it too late already? That is the question. Climate change leads to reduced agricultural production, and agriculture can no longer sustain livelihood of farmers and their families in many parts of the world. In some parts of the world, people migrate to seek better opportunities. According to the World Bank, there will be 216 million migrants by 2050, mostly in sub-Saharan Africa, South Asia, and Latin America. With changing precipitation patterns, many parts of the world will be too dry to live. We know the cause. but instead of a greenhouse gas emissions reduction, the emissions are increasing, as we can see here in the graph. In order to limit global warming to 1.5 degrees, the world needs a rapid, immediate greenhouse gas emissions reduction to limit the global warming. This is what we call mitigation, but for us, universities, there is not much we can do in our curricula. We are the academic community, and the question is, what can we do as academe? Should our students read more books? I think we should make our education attractive and effective. We should also focus on climate adaptation. We should teach our students what measures can be taken in our cities, in our neighborhoods, in our communities to adapt to a changing climate. A changing climate of more intense periods of precipitation, floods, forest fires, and heat waves. We must teach our students how to adapt to the new normal. I will show you some examples on how I do that at my university. The first tool is the creation of a context-rich learning environment and expose students to real-life problems. So these problems can be local, national, or international. A best practice is what we call Climate Café. This picture on the screen is from the River Challenge 2023 in April this year in the Philippines. We worked together with the University of San Carlos. We brought Dutch and Filipino students together in different teams, and during a 2 weeks pressure cooker, they worked on solutions to reduce the river pollution and to improve the flood management. We exposed them to extremely dirty rivers that are considered biologically dead. The challenge was about to assess the pollution and the current situation, and we gave them methods on how to assess the current situation and how to do measurements. So the challenge for the students was how to formulate feasible solutions and to present them to the local government. So the solutions should be feasible so that they can actually be implemented by the local government, because often the local government also has no clue how to solve this problem. So the students learned how to work in an international, intercultural setting. We use the approach of Climate Café also in the Netherlands, on weekend problems in the Netherlands, and we work with stakeholders in the Netherlands, but also on international climate cafés. Climate Café is a nice method to work on wicked problems for which not one stakeholder is responsible. Like this river pollution, not one stakeholder is able to solve this problem. So it's really important that different stakeholders work together to solve the problem. The second example that I want to show to you is the field lab in the Hillesluis district. Hillesluis is a densely populated low-income neighborhood located at the south bank of the city. We call the center a Neighborhood Information Center on Climate Change. We found out that the members of the community know something about climate change, but that they don't know how to adapt. What measures can they take themselves in their own garden, in their own house, in their own street to reduce the heat stress and to reduce the risks of flooding? This picture is a playground managed by the community. 2 years ago, it used to be a concrete square so that children could play ball games. So together with the community, we made a new, and the students, we made a new design for this playground. In a former situation, during the summertime, it was extremely hot, there was no shadow, it was only concrete. And during the rainy season, very often when heavy rain in this area, the children could not play because of the water nuisance. The water could not infiltrate. With the help of the students and the community members, we were able to make a new design that is green, much more pleasant. It has a fruit garden, fruit trees, vegetable garden, and now the next phase is that we're going to put information panels about climate adaptive measures. We use the neighborhood center as a starting point for our community-based research with our students. We want to be present in the neighborhoods and we want to build a good relation with the neighborhood members. And that we want all that our research benefits immediately the community. We also want to create awareness about climate change among the community members, and we want to work on climate inclusiveness. We don't use the community only for filling in our questionnaires, but to work together with them in equality. We use the field lab as a starting point for various awareness and education activities in the neighborhood. This picture is an example of a green neighborhood excursion facilitated by a student. She organized this tour to show residents and stakeholders about green measures that residents can take to improve the biodiversity, the green space, and to reduce heat stress. This, for example, is a green facade garden. Residents in Rotterdam can get a subsidy from the city if they take out concrete tiles and replace it with green and plants. The tour is available on Google Maps. If residents scan the QR code, they can follow the route through the neighborhood with their smartphone, and it contains more information about green measures they can take and how they can avail of the subsidy. Another example of community involvement in climate adaptation is the street climate card. Together with my students, I developed a street climate card. We score different measures in the street and we end up with a score. The score corresponds with a label. Label A is a good score and your street is green and has adaptive measures. With label H, your street scores low and is red, and action should be taken. With the street climate card, we can residents can easily assess and score their own street. This tool creates awareness, and residents ask us why their label is red and what can they do to improve the score of their street. What can they do to improve their living environment? So this is a very interesting tool that we do together with community members. If you scan the QR code, you can open the publication that we recently published. We use the climate card in our course Water Management. A selected street is assigned to a group of students. They must assess the streets and propose solutions to reduce heat stress and increase infiltration capacity. For different measures, they must undertake a cost-benefit analysis and they must determine the effect of different measures on heat stress reduction and water problems. Then the students must discuss their proposed solution with stakeholders to determine if their solution has enough support. A very interesting website with a lot of practical measures against heat stress and water nuisance can be seen if you scan the QR code on the top right side. Number 3, use innovative teaching materials. For example, in our education, we use Climate Scan a lot. You can scan the QR code and you will reach at the website. If you register, you can also scan immediately green solutions that you observe here in Lombok. Climate Scan is an interactive web-based map application for international knowledge exchange on blue and green projects around the globe. It focuses mainly on the topics surrounding the areas of urban resilience, climate proofing, and climate adaptation. The objective of Climate Scan is international knowledge exchange on climate adaptation projects through an interactive web-based application. This global online tool guides users through many brilliant and innovative projects around the world and introduces them to local initiatives. Users can access projects by consulting an interactive map or selecting a specific topic like water, urban agriculture, air quality, energy, etc. For example, the blue dot number 2 on the right side is a project that was uploaded by a team of students. They uploaded their data and pictures from the field study. They uploaded their report and they made a movie. We use the climate scan we use this especially during climate cafe activities and field work, but you can also use it in your classes and you learn students how to observe their environment. I would like to close this presentation with a picture of the lowest part in the Netherlands. This is nearby Rotterdam. This water retention basin is located at 6.74 meters below the sea level, as you can read from the red circle. The red dots on the top right side is the sea level. Each drop of rain that falls in this basin needs to be pumped up 7 meters higher to the river and then discharged into the sea. Each country, each city has its own challenges, and we can only cope with these challenges that face us if we work together. Terima kasih.
Thank you, Professor Rick Haikop. Applause to Pak Rick Haikop. Yeah, let me summarize his presentation, nice presentation. With the impact of global warming, Pak Rick have experience how to educate social community or government to adapt climate change. We are as academician, a lecturer and a student have a challenge how to learn environment and to adapt climate change. And in Rotterdam University have experience first change concrete area to green area. The Rick have example about the ground playground. Last time is almost all concrete, and then they change with green area with good infiltration area. And the second one, the government give subsidize when the commodity can change the area, not have infiltration to infiltration, more infiltration area. And then the third, they have method street climate card. Yeah, this means each student put the card with color green, yellow, and red. Green is the area is still good in environment, and then red is the bad environment. So they can what to do with the condition in the red condition. And they propose about innovation teaching using website and climate cafe, and also learning how the situation in that Rick mentioned the area lowers the sea level in Netherlands with minus 6.7 area below sea level, and how to manage this area be better because climate change and still do. Okay, please applause again to Professor Rick Haikop. Now we arrive in session question and discussion, question and answer. For the first session, I would like to give 3 people to give a question, and before you ask a question or give a comment, please first raise your hand and then mention your name and your institution. Yeah. I like to the question not so waste the time. Yeah. Please, the question can be to Dr. Kamarudin, Ahmad, and then Ibu Hermin, and Dr. Johannes, and Rick Haykop. Please. Yeah. First, and the second? Bu Heni, the second, and then the third. The third question. Okay, we start first the two question from the audience. Please.
Okay, thank you. I want to ask for Associate Prof. Dr. Herman Puji Astuti, SSE, MSE. Okay, let me introduce myself. I am Dara from Engineering Faculty at Al-Azhar Islamic University. I'm a bit curious for your paper. Okay, talk about data analysis. In your paper, you use artificial network ANN to analysis. And my question is, why you chose this program? What the exists this program compare with other programs? Thank you.
Yeah, okay. And a second question.
Okay. My name is Heni from Sultan Agung Islamic University. Hello, Johannes and Rick, my colleagues. How are you? Okay. Yeah. I will ask Johannes. Protecting coastal area using multi-function dike is one of a good solution, I think. And shortly in Semarang, there will be a multi-function dike along north of Semarang, which is above of the dike will function as the toll road. But with a multi-function dike, will certainly have an impact on the environment, ecosystem balance, and socio-economics of community in coastal area. And also, build the multifunction dike is not cheap. Yeah, it will be very expensive. So, what is about your opinion about the impact on the environment and also on socio-economics of community who living along of the coastal area? Thank you.
Okay. Another question, please. Yeah. Yeah, Pak Ari, please.
Thank you. My question is for Rick. Rick Haykop. What about your opinion? Because today in a lot of area in Indonesia, there's a lot of land use change, especially for housing. There's a lot of rice field change to housing nowadays. And I think it gives a lot of impacts, especially in the last year, I think in the new year, we are facing the flood, and I think it's one kind of factor that result from the change of land use. And the government also agree with that. So, in your opinion, how we can make local government to realize that climate change can make a huge impact for human life? Thank you.
Okay, so yeah, I have a last question to Dr. Kamarudin. Yeah? How the development of piling house, yeah, in Malaysia, because in Indonesia some areas still have piling house, rumah panggung, yeah, in certain area, and how it's a development in Malaysia first, and the second one about the PU adductive, polyurethan, to stabilize clay marine. Have you experience to implement this method, yeah, PU material to make a better stability of clay marine? Okay, I think we have a question for all presenter. We start from the first invited speaker. Yeah? Please, Dr. Kamarudin.
Okay, thank you for the question, Professor Imam. About the cost that you asked me in terms of the piling cost, I'm sorry because actually I didn't study on the cost because we are just studying in terms of the improvement in terms of the bearing capacity of the soil using this deep cement mixing. So I have no answer for that in terms of the cost. So in terms of the polyurethane, okay, as I mentioned earlier in my presentation, the material that I presented is more on this what they call laboratory scale experiments. We have never tried at site. So because we just tried implement what's available in the lab first, and then if possible, maybe some industrial partners, maybe they can start experimenting at site. Yeah, I think that's all that I can say or respond to your question, Prof. Imam. Back to you, Prof. Iman.
Okay, thank you. We wait for your implementation to the field, yeah, your research. I think it's a very interesting research to
okay,
make
thank you.
Stabilization of clay marine. Thank you, Dr. Kamarudin. And the second invited speaker, please, Bu Hermin, answer the question.
Okay, thank you to Ibu Dara. Yes, the question about the method, yeah, why I choose this method is artificial neural network with the backpropagation model. There are many tools to predict or to calculation about the draft. Which there's a number of tools to monitor. One of the models is there needs for the number of the data, and one of the especially about the INN, there can classification from the problem, and then INN is to can predict and analyze, as this is the assumption to reduce for many data to predict or to classification from this problem. Especially this is the draft index. In recent years, the improve the accuracy of the draft. This is and to modeling method and to remove limitation of the previous method, and due to the need for precise and costly from the data and the fact of the model, this is could not be applied to another area, and this several hydrological technique studies they applied to the INN model. This is my answer. Thank you.
Okay, for the third invited speaker, Dr. Johannes Herpex, please respond the question from Dr. Henny. Please, Johannes.
Yes, thank you very much for the question, Ibu Henny, and nice to see you at least briefly again. Yeah, I think it's a good question. Of course, the impacts of this multifunctional dike, they are there and they are very real. We've seen the cutting down of mangroves in the course of the construction site. We also see that the access of people to those areas is increasingly limited, and those are people that have experienced the submergence of their land before. So we have a situation here where although the dike obviously is built into the sea, it's not a tabula rasa situation on which the dike is built, and there are people that have claims that still have claims to the land, so the question of compensation is also out there, and it's a tricky one because it's a new situation. How do you compensate people for land that is already submerged? So the challenges, I think, are quite high, and but at the same time, there's no way around it. I think it's clear that the dike is going to be built, and so probably a bit related to what Rick just showed us. In those situations, then of course it's important to accompany those changes, and that's probably a bit easier when it comes to those ecological questions. Although of course it's also challenging, and there are compensation measures. For example, the replantation of mangrove forests in other areas, which are also not easy, but they are happening. And it gets more complicated then, of course, with those social questions and the impacts and the losses of people that are directly impacted by the construction of the dike. So, but there have to be accompanying measures, and so I think we have to be optimistic that those are ongoing, and there are ways of compensating people adequately for their limits that are caused by those infrastructures. I think I'll leave it here. But thanks again for the question.
Thank you, Dr. Johannes Herbert. Please, for the fourth invited speaker, Rick Jacob, to answer the question.
Yeah, thank you, Pak Ari, for your interesting question. Yes, of course, urban development is very important, and land use change is a huge challenge. So I think it's very important that if we develop new neighborhoods, so we take into account the urban ecosystem services. So meaning that we, in our new neighborhoods, the extension of our cities, we provide enough greenery, provide shadow, so that we are prepared for heat waves. Also, we provide infiltration capacity, so that in periods of heavy precipitation, the water can infiltrate. So if I look here in my own city, Rotterdam, we see that the old neighborhoods, we are slowly changing. to increase now the infiltration capacity and to increase shadow to address heat waves. And I think also in Indonesia, it should be taken into account that we have to prepare for the new normal, meaning that the temperatures will rise, periods of heavy precipitation. So that should be taken into account when you design new neighborhoods or new urban developments. I hope this answers your question. So ecosystem services, that's very important to look at. Thank you.
Okay, I think the time is almost finished, yeah? So, yeah, I summarize for the question and answer. First, PU have already interesting result from experiment, and we wait for implementation of PU to make a better sky marine condition. And then the second artificial neural network have using for analysis to forecast the drought and how to anticipate or to mitigate drought kekeringan in case study in Rembang Regency in central Java. And then the third multi-function dike, not only technical aspect that we work, but also interesting the impact, and then social and communication aspect, how to implement the multifunction dike as a case study in Semarang in this time. And then the last stakeholders is very important, not only in European, but especially in Indonesia, stakeholders is very important, how to make more green area, more area can infiltrate water to the ground, government, and then neighborhood, and academician, lecturer and student also need to inform the environment to be better, make a green area, more infiltration area. Yeah, I think it's, sorry? Oh, yeah. Have another question from online participant? Please? I forget. We have many participants, not only in the room, but online participant. Okay, but the time is up, yeah. So, thank you to Pak Dr. Kamarudin Ahmad. Thank you to Bu Dr. Hermin Puji Astuti. Thank you to Dr. Johannes Herbeck from Germany, and Professor Rick Heikop from Rotterdam University in the Netherlands. Thank you very much for joining this section, and give a big applause to all of the great speaker. And also thank you for all participants in the room and in the online Zoom meeting. Thank you for all the session. We finished the session, and I give to Master of Ceremony to continue the conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. And have a nice lunch. Please.
Check. Yeah, thank you very much, Prof. Muhammad Wahyudi. Are the speakers still in Zoom online? Can we have photo together with all speakers in Zoom online, Bu Hermin and Prof. Imam? Ya. Hai Jo, Rick, and Pak Kamarudin, apakah masih di Zoom online? Ya, please, we will have photo together with all speakers.
Masih online.
Okay, please turn on the camera for all speakers and participants, and we will have 1, 2, 3 action. Yeah, thank you so much, everyone. Danke, Johannes, and also Rick. Terima kasih. Terima kasih Pak Kamarudin juga. Thank you for all speakers today. See you next time.
Sama-sama kembali.
Okay.
Okay, ladies and gentlemen, thank you to Prof. Imam, all invited speakers, questioners in the discussion, and all online and offline participants. We are now entering lunch and prayer time. Please go to the restaurant near the beach. We will meet again in this room at 2 p.m. Lombok time. Okay, thank you.
Kami persilakan kepada seluruh peserta yang ada di ruangan ini untuk menikmati hidangan di restoran yang ada di belakang gedung ini, yang di dekat pantai. Dan mohon kembali ke ruangan ini untuk melakukan parallel session di jam 2 WITA. Bagi peserta online, for online Zoom participants, please be ready for your presentation 20 minutes before your presentation time. Thank you. Well, for all participants in online Zoom, please be ready in your place because we will separate you to your divided room. Please make sure your instant internet connection is stable, and also please make sure your schedule is now Central Indonesian time at 2:22 WITA Central Indonesian time. Please everyone be ready because the committee will separate your room, will make breakout room for you all. Untuk partisipan, untuk peserta Zoom online, presenter online, kami mohon untuk segera menempatkan diri dan turn on kamera dan pastikan sesuai jadwal presenter masing-masing untuk segera kami separate ke breakout room masing-masing. Diskusi akan dipimpin oleh moderator di masing-masing breakout room, jadi kami mohon untuk segera mempersiapkan diri. Terima kasih.
Halo Pak Busrin. Ya, baik. Sudah mulai, Pak? Belum. Mau kemana, bro? Mau olahraga dulu. Olahraga apa? Basket. Ini. Ngeri. Pemain basket.
Ada pula nih, ada apa nih? Masker tulis. Aku 30 sekali dananya. Mana? Pak, 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 Kak Rahman. Kak Rahman. Hah? Ini aku Pak, ada. Ini pakai apa? Bisa.
Ini doang pasti cepat. Bau ya? Bau. Kamu sudah ada aja. Ada Pak. Green. Hah? Green. Oh iya.
Ojo, dipanggil. Apa yang dijemput Anda? Yang dijemput siapa Anda?
Iya. Iya, nggak apa-apa. Nggak apa-apa.
Ambil satu. Oke dah, makasih. Saya disuruh ke kampus sama Pak RT.
Masuk. Udah mulai? Belum? Belum.
Master Yusuf.
Recording stopped. Recording in progress.
Universitas Islam Sultan Agung Unisula was founded by Sultan Agung Wakaf Foundation on May 20, 1962 in Semarang, Central Java. Unisula gives an important contribution to the world of education, and now it continues to grow and develop to become the best Islamic university in Indonesia. Alhamdulillah, by the leadership of the Rector, Professor Dr. Gunarto SHMH, Unisula successfully achieved superior accreditation. Unisula is committed to achieve the vision of raising Khairul Ummah generation. Khairul Ummah generation is the best generation to create a generation who will faith, devote, and doing goodness. To achieve this, Unisula will be persistent in implementing Islamic academic culture and the concept of Birrul Walidain campus. So it is expected to raise a competent generation, precious-hearted, and also caring and devoted with parents.
Pernahkah terbayangkan Anda menjalani proses belajar di perguruan tinggi yang fokus mengembangkan ilmu pengetahuan yang berwawasan kepariwisataan dan berdasarkan nilai Islam rahmatan lil alamin? Selamat datang di Unizar, Universitas Islam Al-Azhar. Sebuah kampus di Pulau Lombok, Nusa Tenggara Barat yang berdiri pada tanggal 10 Mei 1981 di bawah Yayasan Pesantren Nuur Al-Azhar, memiliki visi menjadi universitas terkemuka dalam pengembangan ilmu pengetahuan dan teknologi berwawasan kepariwisataan yang profesional dan berintegritas berdasarkan nilai Islam rahmatan lil alamin, dengan tujuan menghasilkan lulusan berkarakter yang menguasai ilmu pengetahuan dan teknologi dengan menerapkan nilai humaniora dan Islam demi kemajuan bangsa, peradaban, dan kesejahteraan manusia. Sebuah tempat untuk mengalami proses belajar dan menempa diri dengan 7 pilihan fakultas dengan belasan program studi yang hampir seluruhnya terakreditasi baik sekali. Fakultas Ekonomi dan Bisnis, Fakultas Teknik, Fakultas Pertanian, Fakultas Hukum, Fakultas MIPA, Fakultas Kedokteran, dan Fakultas Agama Islam. Menyediakan program kelas pagi bagi para fresh graduate dan kelas sore bagi para pekerja, karyawan, dan entrepreneur. Unizar aktif menggelar kegiatan seminar baik skala lokal, nasional, maupun internasional. Sebuah kampus swasta dengan puluhan mitra kerjasama baik dengan lembaga pemerintah di lingkup desa, kabupaten, hingga provinsi, BUMN, BUMD, perguruan tinggi negeri dan swasta, baik di dalam maupun luar negeri, serta berbagai perusahaan dan industri. Berdiri di atas lahan seluas hampir 10 hektar, Unizar dilengkapi dengan berbagai fasilitas penunjang pendidikan dan penelitian. Didukung oleh dosen-dosen profesional, lulusan dalam dan luar negeri yang ahli di bidangnya, Unizar siap mengantarkan Anda mencapai impian dan meningkatkan karir dalam dunia kerja. Menyediakan ruang eksplorasi diri dalam berbagai unit kegiatan mahasiswa dan organisasi kemahasiswaan yang telah menghasilkan beragam prestasi mahasiswa. Senantiasa bertekad untuk menghasilkan insan yang adaptif dengan perkembangan zaman, memiliki kepekaan dalam dinamika sosial kemasyarakatan, menjadi solusi dalam berbagai permasalahan kemanusiaan sebagai wujud keimanan kepada Tuhan semesta alam yang Maha Pengasih lagi Maha Penyayang. Dengan segala dedikasi, kami siap menjadi bagian dari terwujudnya impian besar Anda. Siapkah Anda menjadi bagian dari keluarga besar Sivitas Akademika Universitas Islam Al-Azhar?
Check. Everyone, we will continue our agenda today. Ladies and gentlemen, dear distinguished guests and participants, dear sisters and brothers, thanks to all participants and presenters both online and offline for having very nice presentation today. And also, we give big applause to all moderators, team timekeeper, and also for all the team of presentation today.
Yes.
Before we close our agenda, we would like to go to give some awards to all awardees today. Are you ready, guys? Yeah, okay then. For online participant, please be ready because this award will go to online and offline participant.
Okay, ladies and gentlemen, now I am announcing the best paper winners. There are 3 winners. The first is Iwet Mulyani. The second is Adidi Setio Purwantoro. And the last is Jamila Kautsari. Congratulations.
Congratulations for
all the winners.
Yeah.
Certificates will be sent to your email.
Congratulations one more. Okay, now I will announce the best presenters for offline class. The first awardee is, please come forward, Efrianti Cynthia Dewi. The next is Mutia Anggraini. And the last, Agung Wahyudi Biantoro. Please come forward to have the souvenir from the committee. We please our co-chairman, Mr. Saifuddin, to give the souvenir and also the certificate. We can take photo together with all awardees, please. Thank you so much, and once more, congratulations for all awardee. The next is Best Presenters for online participant. We have 5 awardee. The first is Rizkiana Sidkiatul Hamdani, sorry. Number 2, Nisa Ul Aziza. Next is Muhammad Rianto. Next, Ignatius Sudarsono. And the last is Diva Rahma. Congratulations for all of you, and the certificate will be sent by your email. Thank you.
Okay, ladies and gentlemen. Finally, we have to close our agenda today. Please welcome the Dean of Engineering Faculty, Unisula, Mr. Insinyur Rahmat Mudiono, MT, PhD. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Wa bihi nasta'inu ala umurid dunya waddin. Wal aqibatu lil muttaqin. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad amma ba'd. His Excellency, the Rector of Universitas Islam Sultan Agung, Unisula, Semarang. His Excellency, the Rector of Universitas Islam Al-Azhar, Unizar, West Nusa Tenggara. Honorable the Indonesia Minister of Public Works and Housing. Honorable the interim of West Nusa Tenggara Province Governor. Honorable all invited speakers, respectable all participants, ladies and gentlemen. First of all, I would like to congratulate all team of 5 international conference on coastal and delta area ICCDA 2023 who were successfully conducted a hybrid conference, a primary platform for the presentation of new advance and research results. Time to time, the conference topics are developed and more interesting. This year, we have plan, design, and construction to develop smart infrastructure in coastal and delta areas. Climate change challenges, disaster mitigation, and infrastructure in coastal and delta areas. Sustainability, development in coastal and delta areas. Policy, social economics, law, and multi-aspect to build environment in coastal and delta areas. Hopefully, collaboration among universities can be continued and the relationship becomes closer. Finally, I would like to thank all the community members for organizing this conference and ensure it ran well. I would also like to apologize for any inconvenience that might experience during this conference. Ladies and gentlemen, I thank you once again for your participation. I do also hope that we can meet again in the next conference, insyaAllah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Mr. Dean of Engineering Faculty, Unisula. Okay, ladies and gentlemen, dear brothers and sisters, before we close formally this event, let's show you all our organizing committee's activities for today's event. Please enjoy. What a really nice video. We thank you so much for all committees, both offline and online. Say hi to online committee in Unisula. We did a great job, guys. Thank you so much. And also for Unizar, our main co-host. We are proud to collaborate with Unizar. Hopefully next year, in the next year, we can collaborate each other again. I mean, for IT team, you are very great, everyone. Thank you so much for all committee. Thank you so much, everyone. So next year we will have this kind of agenda. Where will we have this conference? Maybe, Prof. Imam, where will we have the conference next year? Maybe. After next year. Where is it? In Netherlands or in France maybe? Okay, well, ladies and gentlemen, please, Mr. Yuda.
Okay, thank you. Ladies and gentlemen, the ceremony has come to the end. Thank you everyone for your presence and we really appreciate it. This is the end of the ceremony. See you next year, inshallah. Maybe in another country.
Yeah, okay, the last we say, wassalamualaikum warahmatullahi wabarakatuh. To all committee and participants, maybe we can have photo together here in front of the stage, please. Go, semua participants, presenters.
Baik, selamat malam Bapak Ibu sekalian. Diumumkan setelah ini masih ada jamuan makan malam di tempat yang sama tadi di dekat pantai pukul 7 kurang lebih nanti. Jadi silakan nanti menuju tempat makan malam. Terima kasih. Untuk para peserta yang di Zoom meeting sudah bisa meninggalkan ruangan meeting online. Terima kasih.